In this session, we will be discussing all the ISI previous year questions from the chapter of limits. Before starting off with the PYQs, let us first quickly recall some of the important concepts over here regarding limits. Okay, just briefly, I'll just go through some of the major points, some of the most important points, and then we'll move on to the questions. Okay. So, quick points to be noted before we start off with limits. Like I say, these are just basic revision points which you need to know. Okay, so you should be familiar with the definition of a limit of function for a point, which is the basic definition. What is this? The definition of limit, right? Limit extending to a minus fx. The left hand limit and the right hand limit must be equal, and this has to be a finite quantity. Okay, just quickly I'll go through all the points. Okay, point number 2, what are the 7 indeterminate forms? जो कि forms होता है, the standard forms which is based on which the entire chapter is built upon. Okay, the 7 important forms are basically 0 by 0, infinity by infinity, 0 times of infinity, infinity minus infinity, infinity raised to the power of 0, 0 raised to the power of 0, and 1 raised to the power of infinity. So these are the 7 indeterminate forms actually which we will, which we do actually. ठीक है, तो 0 by 0 form and infinity by infinity form are the most common forms. Okay, these two, the first two are the most common forms of questions you will see. ठीक है, and basically you must need to know how to solve the questions of each of these forms. The main thing is that only you just need to know how to solve the questions of each of these forms, and hopefully you all know this thing. Okay, and these are your standard methods to solve a particular limit question: factorization, rationalization, substitution, binomial approximation, or Maclaurin series expansions. So these are your standard methods actually. How do we solve a particular limit, right? Either you factorize it or you rationalize it, okay, or you substitute something, like take something as t and then solve, or use binomial approximation, है ना, जो कि basically था 1 plus x raised to the power of n. If x is small, then you can approximate this and write this as 1 plus nx. You can write this thing. Then Maclaurin series expansions. I hope you people remember what are the series expansions. Series expansions are extremely important for question solving. I'm saying this thing. Most of the questions, not most of the questions, but I have seen every year there has been questions where series expansions were used. Okay, so series, ISI people love series expansions. So please, this section you need to remember all the series. Acha, then algebra of limits. So again, this is something which is very common. You can distribute the limits over summation. Limits is distributive. Sorry. You can distribute the limits over summation. Limits is distributive over summation or product also. Limit is distributive. Okay, so you can just simply distribute the limits to this function and the next function. Similarly, the product of two functions is given. You can distribute the limits in terms of product. And if a constant is present, which is independent of the limit, if a constant is present, so you can simply take out the constant and simply distribute the limits with the remaining function, which is containing x. Again, in case of division form, then you can also distribute the limits over here, like in the numerator and on in the denominator, you can simply distribute the limits. Okay, and point number E says, the last point, which is saying that if fx is more than gx, then limit extending to a fx will be also more than gx. Obvious reasons, if the function f is more than the function g, so their limit in quantity will be also more than the limit in quantity of g. The limits will be also more. Quite obvious thing actually. Okay, and these are the basic algebra of limits. And there comes the sandwich theorem. What is a sandwich theorem? Sandwich theorem is basically something which is, very important from the inequalities point of view. Okay, sandwich theorem is something which is extremely important from the inequalities point of view. जानते तो हो ही basically. So whenever, let's say, for instance, a function a is there, you have two functions, first of all, three functions. In fact, three functions are there which is satisfying this inequality. Hx is one function, gx is one function, and fx is one more function. Gx is such that gx is lying in between h and f, like this way. Okay, and they are kind of closely related actually. Take a very close actually. They are forming a very close value over here. At a, you can see over here, at a the limiting value is very close. At a, limit x tending to a fx or gx is basically the same as L. Okay, limit x tending to fx and hx, limit x tending to a fx and limit x tending to a hx, fx and hx, both of them at a, the limiting value is basically L. At a, they are so closely related basically, so their limiting value at a is basically L. Okay, so this means that if this satisfies and if this inequality holds, then the middle function will also tend to L. If these two functions are tending to L as x tends to a, then the middle function will also tend to a. And based on this, we have lots of good questions. Okay, based on this inequality, and mostly you will see the questions based on inequalities are actually solved using sandwich theorem. Inequality wala questions, or let's say whether you have to form some inequality or not, those questions are technically solved by sandwich theorem, right? So if these two extreme functions are tending to L, then the middle function will also tend to L as x tends to a, which is very clear from the diagram itself. Again, these are some standard limits, which you are supposed to remember them. These are some trigonometric limits. Limit extending to 0 sin x upon x is 1. In fact, this is not technically not 1. We will call it as 1, but this is actually less than 1 minus. If you remember the graph, we'll see the graph as well, but this is limit extending to 0 sin x upon x is basically 1. Similarly, tan x upon x is 1, and so on the remaining others. Okay, so these are some standard limits. You are supposed to remember them. Similarly, like 1 minus cos x upon x square is limit extending to 0. This is basically half. So these are some of the trigonometric limits. And then you have the list of the exponential limits, exponential and log base limits. E raised to the power of x minus 1 divided by x is 1. Again, like I have said, you are supposed to remember the format, right? Same thing goes for all the limits over here. You're supposed to remember the formats over here. Okay, like this way, this limit and this limit have the same meaning. I hope you people know this thing. Limit extending to infinity, sine of let's say 1 by x divided by 1 by x. This is also 1. Like I have said this thing, you are supposed to remember the format. This is the format, right? As x tends to 0, sine x divided by x. Same divided by sine of same divided by same is tending to 1, right? Same divided by same. And as that same quantity should tend to 0 as x tends to 0. So similarly over here, see, as x tends to infinity, 1 by x will tend to 0. This will tend to 0. This will also tend to 0. So yes, this will be also 1. So this is what I was saying. You are supposed to remember the format over here. The format is extremely, extremely important. The same thing goes over here regarding the exponential limits. You can see over here, this is e raised to the power of x minus 1. So e raised to the power of same minus 1 divided by same. Okay, and this same quantity should tend to 0 as limit x tends to something, whatever. This should tend to 0. This box quantity should tend to 0. Same divided by same. Okay, then you can say this is basically 1. Okay, I hope this much you can understand over here. Okay. And similarly, the next one, ln 1 plus x, limit x tending to 0, ln 1 plus x divided by x is 1. Also, you can use L'Hopital's rule over here to prove this thing. You can directly differentiate the numerator as well as the denominator. You will obtain this to be 1 itself and then simply plug in the limits. I hope you people know what is the L'Hopital's rule, a very common rule. Okay, so these are some of the standard exponential and logarithmic limits you are supposed to remember. Limit extending to 0, 1 plus x whole to the power of 1 by x is e. And last one is limit extending to 0, a raised to the power of x minus 1. Again, the fourth one is not widely used, but this is a very nice limit. You are supposed to remember this thing because this is a kind of a general version of the first one. Okay, so general version of the first one. A raised to the power of x minus 1 divided by x. And also, I hope you people remember, let's say you want to prove this one, then you will differentiate the numerator as well as the denominator. So basically what you will do is limit extending to 0. By the L'Hopital's rule, you will differentiate the numerator, and the differentiation of a raised to the power of x is a raised to the power of x ln a. I hope you people remember this differentiation. This is something which is very important, divided by 1. And then you can plug in the limit. So a raised to the power of 0 is 1 only. Okay, so and you're left out with ln a only. Anyway, so you can prove all these limits using the L'Hopital's rule. So the thing is, we will be seeing the direct applications of all these limits. Okay. And the one which I was saying over here, that limit extending to 0 sin x upon x is 1. Technically, this is not 1. It is actually less than 1, right? Because sin x upon x is always less than 1. How do we know this thing from the graph itself? Let's see the graph. Let's see the graph itself. Dekho bhai, sin x upon x, limit extending to 0, sin x upon x is always less than 1. Okay, we write this as 1, but that is technically 1 minus. And limit extending to 0 sin x upon x. Okay, when x is very small, this will become 1 minus. Okay, we ignore the difference over there and simply write this as 1, but technically the thing is 1 minus. No? So sin x upon x is less than 1. Why? Because you can see from the graph now, these graphs over here, these graphs are extremely, extremely important. Please do remember the graph of sin x, tan x, and x over here. I have given all three graphs in the single graph itself. Okay, the graph of x, tan x, as well as sin x. These are the positioning of the graph. These three graphs are extremely important over here. You can generate lots of things. Let's say, for instance, when x is positive, over here, you can clearly see here the graph of x lies above the graph of sine x, right? So x is more than sine x over here. When x is positive, the graph of x lies above the graph of sine x. So x is positive, x is more than sine x. So x is more than sine x, mane sin x upon x will be what? Less than 1. Sin x upon x is what? Less than 1. And similarly, when x is less than 0, what happens over here? The graph of x, here, this is the graph of the blue graph is the graph of x. And this red graph is the graph of sin x. So when x is less than 0, the graph of the blue graph lies below the graph of the red graph. The blue graph lies below the red graph actually. Okay? So which means I can say that x, here x is what? Less than sin x. Here x is less than sin x. The graph of x lies below the graph of sin x. So x is less than sin x. So when x is less than sin x, now here x is negative. So once you're dividing over here, be very careful. If you're dividing by x, if you're dividing by x, be very careful. The orientation of inequality will change because this here x is a negative quantity. Here x is a negative quantity. Be very careful over here. So in any case, sin x upon x is less than 1. In any case, sin x upon x is still less than 1. So this is basically 1 minus. And the same thing goes with tan x as well. You can do the same thing for tan x. So basically limit x tending to 0, tan x upon x. This fundamental concept must be very clear that tan x upon x, this must be also 1 plus and not 1 minus. Okay, or 1. Exactly not 1, but this is 1 plus, something which is more than 1. This is the very fundamental concept of limit, that limit can never take the exact value. Limit always means you are tending to something. As x tends to 0, your function also tends to some quantity, finite quantity, whatever it is, 1 plus or 1 minus. Okay, it is tending to 1. It is tending to infinity. That's how we deal it actually. So these three graphs are extremely important. You are supposed to remember them by heart. So as the calculations. Okay. Or similarly, we have the graph of the sine inverse x and tan inverse of x. Sine inverse of x divided by x is also more than 1. You know this thing that similarly, as x tends to 0, limit x tending to 0, sine inverse of x divided by x is also 1. Sine inverse x divided by x is also 1. Similarly, tan inverse of x divided by x is also 1, but this one is basically 1 plus. Again, you can see the graph from here itself. These are standard graphs. I hope you know the graphs of tan inverse and sine inverse. You people have done in inverse trigonometry. So this is the graph of sine inverse of x, and this is the graph of tan inverse of x. You can see over here, as x is more than 0, sine inverse of x, the graph of sine inverse of x is lying above the graph of x. So basically we can say sine inverse of x. Here sine inverse of x is more than x. Okay. Sine inverse of x is more than x. So once you divide this thing, so sine inverse of x divided by x will be more than 1. So this is actually more than 1. So slightly more than 1. As x tends to 0, this will be a quantity which is slightly more than 1. For smaller values of x, this will be a quantity which is slightly more than 1. And the same thing holds for here also. If you take the negative quantity, again, the same thing. Once you take the negative quantity, what will happen? The orientation will change and you'll get back the same thing. Okay. So these are some standard things which are supposed to, standard graphs you are supposed to remember. These are extremely important. And there comes the last thing, which is these forms. So far, we were discussing all those forms like the standard ones, like 0 by 0 form, infinity by, how do we solve questions of 0 by 0, infinity by infinity. Okay, so these are basically the main steps. Okay, the one which you are seeing over here, factorization, rationalization, and binomial approximation, and all sort of things. These are all basically what? These are standard methods to solve questions of 0 by 0 form. Take na, ye wala. These 1, 2, 3, 4, these first 4 forms. You will use these for the first 4 forms. We have these fixed methods. Okay. Now for the remaining last 3, there are all total 7 forms now. So remaining last 3 mein kya hoga? Last 3 ke liye we are having some special cases. Last 3 are the special cases. These are special forms, and you will get lots of questions over here from the last 3 as well. Okay. So the last 3 forms, for 0, 0 raised to the power of 0, infinity raised to the power of 0, and 1 raised to the power of infinity. Out of all these 3 forms, this 1 raised to the power of infinity is very important. Okay. But still, for 0 raised to the power of 0, let's see the first one. For 1 raised to the power of infinity, what we'll do is, we have a direct formula. What is it? Basically limit extending to, and these are quite common things. You know, you will find this in most of the books. Okay, that if 1 raised to the power of infinity is there, if you're finding after plugging the limits, you are seeing the form is 1 raised to the power of infinity. I hope you know this thing, that always for limit questions, what we do is we always check the form first. So for a limit extending to 0, if you are seeing this form 1 raised to the power of infinity, then what will you do? You will directly, you can use this formula, e raised to the power of limit extending to a, gx will come down, this gx comes down, and you will write down fx minus 1. E ke power mein e raised to the power of limit extending to 0, g will come down, and then you will write this as fx minus 1. Limit extending to a, gx into fx minus 1. This is a very standard formula. You can directly use this thing for objective questions, but for subjective questions, you can, if you want to get, you know, decent marks, full marks, you should show the proof of this formula as well for subjective questions. If you want to get decent marks, you should definitely prove this formula. Okay, you should know the proof as well. The proof, I'm not like, I've not given the proof over here, but the thing is, you know the proofs over here. You can definitely find it in your notes. और ये second वाला देखो, second one says for the rest of the forms, I mean for the remaining ones, 0 raised to the power of 0 and infinity raised to the power of 0, for the remaining two forms, what we will do, what we do is we simply take log on both the sides and simply solve, right? For the remaining forms, like let's say for x raised to the power of x as x tends to 0, a very famous question, x raised to the power of x. So what do we do is we just simply take log over here like this, okay, and then simply take limits on both the sides. The left hand side we are having log a, left hand limit extending to 0, left hand side we are having log of a. And limit is dependent on x. So this will still remain to be a log of a, because log of a is just a constant with respect to limit extending to 0. So log of a will be limit extending to 0, x log x, something like this. And then we solve this thing. We convert this x log x. X log x is a very standard form. What do we do is we convert this in this sense, log x divided by 1 by x, and then we solve it. Okay? And then afterwards, we are solving for log a. And then afterwards, what we will do is we'll transfer the value of a by taking e raised to the power of 0, and which will become 1 over here. Log a will be 0, so a will be what? 1. Okay? This is how you are supposed to solve the questions for the remaining forms. For 0 raised to the power of 0 and infinity raised to the power of 0, what you will do, you will simply take log on both the sides and simply simplify. Okay? That's all about the theorems over here. And lastly, we have some standard forms. I mean, you people should be able to utilize these series while solving the question. You have to understand where should I use these kind of series. Okay, and these are the Maclaurin series expansions. Series expansions are extremely important. I'm saying this thing. You have to remember the series. I have given some of the series over here which are extremely important. Sin x, cos x, tan x, e raised to the power of x, ln 1 plus x, 1 plus x raised to the power of 1 by x. These are some of the standard most series expansions. You are supposed to remember them. Okay, so again, we will see the use of this thing with the help of the questions itself. We'll solve the questions and there we'll see the use of this. Okay, so you're supposed to remember all of these series. Chalo. Let us now start off with the previous year questions. Let us start off with this year only. Let us start off with 2025 only. Chalo, first question. First question is, limit is given, limit n tends to infinity n plus 100 raised to the power of 5 upon log of n minus 50 base c. And we have to find the value of L only. Technically, we have to find the value of approximate value of L or some values of L only, basically. Okay. So what is the logic? What is the logic for these kind of questions? Always first you need to see the form. You need to first see the form over here. Therefore, limit n tends to infinity, n plus 100 raised to the power of 5 upon log of something is given. So therefore, form dekho, as n tends to infinity, this will tend to infinity. Okay, and this quantity 5 upon log of n minus 50. So as n tends to infinity, this quantity will tend to infinity. Okay, this niche wala quantity, this quantity will tend to infinity. Fine, and 5 upon infinity will tend to 0. So this is of the form infinity raised to the power of 0. Okay, so now you know the form and now you know the procedure as well. What is the procedure? Basically, you solve this using taking log on both the sides. So simply take log on both the sides and solve. Bas yahi hai. So what I do, I take log on both the sides and I simply solve this thing. So we have log of L. Log of L will be what? Limit n tends to infinity. 5 upon. This will come down. The power will come down. So 5 upon log of n minus 50 base c. And this is log of n plus 100. Both are natural logs. Okay. So 5 is just a constant, so you can take this out. So we are having limit n tends to infinity. So we have log of ln n plus 100 upon ln n minus 50. So next, we are having this to be a standard form, which is infinite raised to the power of infinite divided by infinite. So this is 5 times of limit n tends to infinity. Next, we can use the L'Hopital's rule. So this becomes limit n tends to infinity. 1 upon n plus 100 divided by 1 upon n minus 100, n minus 50. You reciprocal this thing. The form is still not gone. The form is still not gone. Again, we are having this to be n minus 50. This finally becomes n minus 50 divided by n plus 100 over here. Okay. So we can say from here, we are getting once again, if you use this L'Hopital's rule, you'll be getting 1 by 1. So the value of this limit will be 5 in this case. Once again, differentiate this thing. You'll be getting 1 in the numerator and 1 in the denominator. So value of this limit will be 5. So log of L is 5. So L is what? L is e raised to the power of 5. L is e raised to the power of 5. Now e raised to the power of 5, the value of e is 2.718. Or approximately, you all can take it to be 3 raised to the power of 5, let's say. Approximately, I'm saying you all can take it to be 3. And 3 raised to the power of 5 is approximately 243 only. So this quantity is somewhat less than 243. Okay, 2.718 whole raised to the power of 5 will be somewhat less than 243. Okay, so definitely option C must be correct. L must be lying in between 32 and 243 because the maximum range is 243 possible. This cannot exceed beyond 243. So L is less than or equal to 243 and greater than 32. Next question. Okay, this series is given actually. So an is given to be this sum. We have to find limit n tends to infinity an. Okay. Now this is based on sandwich theorem. This question is based on sandwich theorem. Okay, basically you need to establish this inequality over here in order to solve this particular question. You know, there are multiple questions based on this type. One question is basically taught in integration when you learn definite. You know, limits are taught in two places. One is the chapter of limits. And then the second type of questions of limit is basically how to convert series questions of limits into integration format. This question was based on establishing inequalities and then using sandwich theorem. So basically what you need to do is you need to establish this inequality over here. How do you establish this inequality? Here, look at this thing very carefully, how you are supposed to establish this inequality. So you're having n square divided by square root of n to the power of 6 plus 1. Then square root of n raised to the power of 6 plus 2. And so on, this continues. Okay? So, this is basically your n to establish this inequality, because you must have seen over there for sandwich theorem, you must have seen over there that sandwich theorem is valid for inequalities. You need to establish some sort of concrete inequalities so that you get the upper bound as well as the lower bound. You get the upper bound as well as the lower bound. Okay. Then only you can conclude the limiting value. N to the power of 6 plus 1. This is the series given, n square upon square root of n to the power of 6 plus 2. And so on. N square upon square root of n to the power of 6 plus n. Now the lower bound. What is the lower bound and the upper bound? You need to figure out this thing. Okay? Lower bound and upper bound. So look at this thing. As denominator increases, as denominator will increase, if denominator increases, okay, if denominator is very large, then the function value will fall. If denominator is very large, then the function value will fall. Overall fraction will fall. Overall fraction will basically fall. है ना? अरे 1 by 10,000. 1 by 10,000 is a very large quantity. So the fraction will fall. The value will decrease. Right? So what I do is, I'll give the maximum value over here. Maximum denominator. What is it? Square root of n raised to the power of 6 plus n. Square root of n raised to the power of 6 plus n is basically your maximum denominator. Therefore, what I'm doing is I'm giving maximum denominator over here. Maximum denominator to all the terms. Over here on the left hand side. Over here on the left hand side. I'm giving the maximum denominator over here on the left hand side. Okay. Keeping the numerator constant, keeping the numerator constant, because the numerator is same for all the terms. So what I'm just doing is I'm just simply giving the maximum denominator to all the terms on the left hand side. What will happen? Then overall fraction will decrease. So what I'm doing is I'm giving the maximum values over here. देखो maximum value, maximum तो यही है, and then keeping the numerator as it is, n square. Similarly, what I'm doing is I'm giving the minimum value over here. I'm giving the minimum value over here. The minimum denominator will be n raised to the power of 6 plus 1. Na? From all these values, n raised to the power of square root n raised to the power of 6 plus 1 will give you the minimum denominator. The minimum denominator will be obtained from n square root of n raised to the power of 6 plus 1. Okay? And the numerator will be the same. The numerator and n square, n square, n square. So what I have done basically, I have given the maximum values over here, the maximum value, and I have given the minimum values over here. Niche. Minimum values over here. Why? Because if denominator increases, fraction will decrease, and vice versa. I have given the minimum value over here. Why the minimum value over here? Because if denominator is lower comparatively, then the function will increase. Okay? Function will increase actually. This function will increase. If this value is lower, then the overall fraction will increase. If this decreases, then the fraction increases. Hopefully this much is clear to you. Next what? Next, once we are forming this inequality, next we are supposed to solve this thing by taking the limits over here. What is this? N square plus square root of n to the power of 6 plus n square upon square root of n to the power of 6 of n, and so on. How many terms are there? All total n terms are there. So all total n terms means n times of this quantity. So n times of n square means n cube divided by square root of n to the power of 6 plus n is less than. Now this quantity is nothing but your a n only. And this is n. Similarly, n number of quantities are there. So n times of n square divided by square root of n raised to the power of 6 plus 1. So that's basically n cube divided by square root of n raised to the power of 6 plus 1. Okay? So next take limit n tends to infinity over here. On both the sides, I'm taking limit n tends to infinity. Next, we'll be solving this thing. ठीक है, तो solve कर लो. How do we solve this thing? n cube divided by square root of n to the power of 6 plus n. So what is the best way to solve this thing? So you simply take out the highest power common. Therefore, you have solved. You simply take out the highest power common over here. Simply take out the highest power common and simply solve. So n cube divided by, here we are having the highest power is basically n raised to the power of 6. This will come out of the square root and this will become n square. This will come out and this will become n square. Sorry, n cube. This will become n cube. That's a shortcut. You have used the shortcut. बहुत अच्छे. So 1 plus n upon n to the power of 6. So n upon n to the power of 6 means 1 upon n to the power of 5. You can see over here this will cancel out. And similarly, this is what they're asking for. Limit n tends to infinity. N is limit n tends to infinity. This is n cube divided by, similarly, you take out the highest power common. So this will become 1 upon n cube will come out, n cube and n cube will cancel out. What is remaining? 1 upon square root of 1 plus 1 upon n to the power of 6. Now you can just directly plug in the limits over here. You can clearly see this as n tends to infinity. This will tend to 0 and this will also tend to 0. So you are left out with 1 only. Right? So what is the limiting value? 1. This is 1. The upper limit is 1. The lower limit is also 1. So overall limit will what? Tend to 1 only. So limit n tends to infinity, an will be 1 only. So option B must be correct. This is equal to 1. Let's come down to the next question. The next question says, let k be a positive integer and fx is e raised to the power of x minus 1. Then we have to find the value of this particular limit. Limit n tends to infinity, fx plus f of x by 2 plus f of x upon 2 square and so on. F of x upon 2 raised to the power of k upon x. This is a very simple question, direct format based question. So you just plug in the functions over here. So limit n tends to infinity, fx is e raised to the power of x minus 1. Okay, plus f of x by 2 will be what? E raised to the power of x by 2 minus 1. Okay, then e raised to the power of x by 2 square minus 1. and so on. This continues till e raised to the power of x by 2 to the power of k minus of 1. Okay, and divided by x. So the best thing is to just divide by x on all of these things, because you can clearly see, you will get the pattern from here. You will get the pattern from here. Exponential limit, format, exponential limit x tending to 0, e raised to the power of x minus 1 divided by x. This will be 1. Okay, so e raised to the power of x minus 1 divided by x. Acha, यहाँ पे limit n tends to infinity is given. No, printing mistake. Oh, no. This is printing mistake. This will be x tends to 0 only. This is x tending to 0. Printing mistake. X tends to 0. N tends to infinity. Now, where is n? X tends to 0 yoga. Typing error. X tends to 0. So x tends to 0, e raised to the power of x minus 1 divided by x. So limit x tending to 0, e raised to the power of x minus 1 will be 1 only. Okay, this will be 1. But afterwards, we'll plug in all the values. Let us adjust this first. E raised to the power of x by 2. Same by same format we need. X by 2 minus 1 divided by x. So x by 2 is needed. So extra, how much we are taking? Extra, we are taking 2 over here. So 1 by 2 basically. है ना? याद है ना? E raised to the power of same minus 1 divided by same. Similarly, e raised to the power of x upon 2 square. So x upon 2 square, again, x upon 2 square minus 1 divided by x upon 2 square. 2 square, you are taking 2 square extra. Okay, you're dividing by 2 square, so multiply by 2 square over here. So it's technically 1 by 2 square, and so on. This continues till how much? This will continue till e raised to the power of x. This will continue till e raised to the power of x by 2 to the power of k minus 1 divided by x upon 2 to the power of k. How much you are taking extra? 2 to the power of k. Okay, so now once you distribute the limits over here, this will tend to 1. This portion will tend to 1. This portion will tend to 1, and all these portions will tend to 1 over here. All these portions will tend to 1. So what is remaining? 1 plus 1 by 2. This series will be remaining 1 plus 1 by 2 plus 1 by 2 square, and so on up till 1 by 2 raised to the power of k, which is nothing but a GP. You can clearly see this thing. What is this? A GP, na? है क्या ये GP? तो first term is basically 1. First term is 1. Common ratio is what? Half. First term is 1, common ratio is half. So 1 times of 1 minus half raised to the power of GP formula is known to you. Half raised to the power of k plus 1. Right? Divided by kya? 1 minus half. है ना? 1 minus half. So once you take this reciprocal, so that's basically 2 times of 1 minus half raised to the power of k plus 1. 2 times of 1 minus half raised to the power of k plus 1. Right? So that's basically 2 times of 1 upon 1 minus 1 upon 2 raised to the power of k plus 1, and again you multiply with a 2 over here, so that's 2 minus 1 upon 2 raised to the power of k minus 1, then minus 1, k plus 1 minus 1, so that's basically 2 raised to the power of k only. So 2 minus 1 upon 2 raised to the power of k, option A must be correct. Next question is, once again, this product series is given and we have to find the limiting value. Limit n tends to infinity an. Okay, this product series is given, and you won't believe that this question was directly given from the notes itself. Like one of my notes had this question, and there is a proper method to solve this question. There was a proper method to solve this question. If you know that method, then the question will be very easy for you. Otherwise, you have to see the cancellations. Like what most of the students have done is they have gone by the cancellation method, which is fine. You just cancel out this thing, like 2 cube minus 1, you will factorize. You will factorize this thing and you will cancel out. Factorize means 2 cube minus 1, so 2 minus 1 times of a cube minus b cube. So 2 cube minus 1 means 2 minus 1 times of 2 square plus 2 plus 1, and so on. And you will see the cancellations, how many terms are getting cancelled out. And cancellations, it's difficult to see the cancellations because the cancellations are not usual over here. Okay, likewise, the first term or third term might get cancelled out. First term will cancel out, third term will cancel out. Take your first term or fourth term might cancel out. The cancellations are completely not usual over here, but if you're going with cancellations, you have to be very careful over here. But if you have done this question before, then you will know something which is called method of indexing. Okay, you will know something which is called the method of indexing over here. You will learn something new over here. If you don't know indexing, see over here. What is the method of indexing over here? First of all, write this into the standard product form. Write this into the standard product form. Dekho, an is what? An is product of what? Product of k is equal to 2 to n. Start from 2 na. So k is equal to 2 to n cube minus 1 divided by, k cube minus 1 kq minus 1 divided by kq plus 1. Hopefully this much is clear to you. I'm just writing the compact form. So product of k is equal to 2 to n kq minus 1 divided by kq plus 1. Okay. Next what? Next we factorize this thing. So k is equal to 2 to n. You will learn something new over here. If you don't know method of indexing, then you will be learning something new over here. K minus 1. Kq minus 1 is basically k minus 1 times of. Let us simplify this as much as possible. So this is basically k minus 1 times of k square plus k plus 1 by the aq minus bq formula, and similarly k minus 1 times of aq plus bq formula. So k plus 1 times of k square minus k plus 1. Hopefully I'm correct. Okay. Next, what they're asking you to find, they're asking you to find limit n tends to infinity. So basically they are asking you to find limit n tends to infinity an, which is the same as limit n tends to infinity over here. Product of k is equal to 2 to n. And can I write this thing directly as, without just writing this so much over here, can I just directly write this thing as, because n tends to infinity over here. So can I just directly write this thing as, this is the same thing as k is equal to 2 to infinity, k minus 1 into k square plus k plus 1 upon k plus 1 into k square minus k plus 1. Okay. And you won't believe that most of the books also, if some standard books are having this particular question, okay, the standard books, some standard books do have this question. And most of the books have actually gone by the cancellation method and not by this method. This is a unique method. Take it. Dekho bhai, k minus 1. Now you know this thing that product is distributive over the product. The product is distributive over product, right? Summation is distributive over summation, like summation of a plus b, summation of a plus summation of b, right? Summation of a plus b, summation a plus summation b. And similarly, product of AB is product of A times of product of B. Product is distributive over product. So what I do is I'll distribute the products to each of these terms. All of these products are dependent on K. So product of K is equal to 1 to n, 2 to infinity, K plus 1. And similarly, product of K is equal to 2 to infinity. We are having K square plus K plus 1 upon product of k is equal to 2 to infinity k square minus k plus 1. Okay. Now the thing is, what is indexing over here? What is the method of indexing? First of all, method of indexing means, listen, I want to match the variables over here. I want to match the variables over here. Like k minus 1 is there, k plus 1 is there. Product is the same, fine. I want to match the variables here. Match means I want to make k over here, k and k over here. Here we are having k minus 1. Here we are having k plus 1. I want to bring this, I want to match these two so that we can have some sort of cancellations. So that the cancellations are clearly visible to us. So the best thing is basically what we can do is we can do the indexing part over here. Now indexing means matching the variables. Let's say I want to change this. We are having k minus 1. I want to change this to k. So k minus 1 to k, which means what you have to do is you have to add 1. Minus 1 plus 1 will give you k. Similarly, here you have to subtract 1. Now note this method. Whenever you are adding 1 over here, if you are adding 1, then what you will have to do is you have to subtract 1 over here. If you are adding 1, then you will subtract 1 over here. If you are adding 1, then you will subtract by 1. If see, variable is increasing, then this here you have to decrease, and vice versa. If here you are decreasing, then here you have to increase. Limits mein. If variable is increasing, then limits will decrease. Okay? Likewise over here, see, you are increasing by 1. So you will decrease by 1 over here. You will decrease by 1. Similarly, you will, same thing over here. You will increase by, you are decreasing by 1. You will increase by 1 over here. You will increase, this will increase. So what do I mean to say is basically this will convert itself into product of, okay, this will become 2 minus 1. So that this will now start from 1. So this new limits are from 1 to infinity. And this will become k. Divided by product of k is equal to, similarly, here what you are doing, here you are subtracting by 1. You are reducing k by 1. So you have to increase by 1. So this will start from 3 to infinity k. Clear? This is 3 to infinity k. So what happens is the variables are matched over here. The variables are simply matched. Otherwise, you can see the cancellations from here also. You can see the cancellations by putting the values over here, but this is basically kind of matching the variable, and this indexing method is valid for summations as well. Now you will ask the question, sir, why are we doing this thing? Why are we doing this thing for only the lower limit? What happens to the upper limit? Upper limit is infinity. Upper limit is infinity. Even if, let's say, you are subtracting something, infinity minus 1 is still infinity. Okay? How this method got derived? This is not kind of, I mean, it's just a basic logic only. Dekho bhai, basic logic only, basic logic only. This is not kind of, hi-fi kind of thing is given. This is a very simple logic, simple method. Simple method is, whenever you are increasing this, you have to decrease the values over here, because to balance this thing out, simple thing is balancing. Simple thing is balancing. देखो product of k is equal to, क्या होता है कि product of, if this starts from product of k is equal to 1 to infinity, ठीक है, then what happens is, अच्छा ये छोड़ो, ये छोड़ो, leave out this thing, start putting the values and verify now. Start putting the values. This is absolutely, you will see there is no change at all. Start putting the values. This is starting from k is equal to 1 to infinity. So 1 into, देखो ना, 1 into 2 into 3 into 4 and so on till k, and simply divided by नीचे वाला part देखो, 3 to infinity. So 3 into 4 into 3 into 4 into 5 and so on till k. So don't you think that these two are the same thing? These two are the same thing. Product of this thing, product of, देखो ना, product of this will be 2 minus 1. 2 minus 1 is what? 1. If this starts from 2, so 2 minus 1 is what? 1. Then 3 minus 1 is what? 2. And so on, so on. You're getting the same thing though. है ना? So basically this is nothing, just the, method of changing the summation thing. Method of changing the summation. The only question is which you people can ask is, ki, sir, why aren't we changing this in the numerator? I mean, sorry, why aren't we changing the upper limit? Why the lower limit? The upper limit should be changed as well. By upper limit is infinity. Infinity minus 1 is still infinity only. So this will not make much difference. If the summation was finite, then you would have done this thing. If the summation was finite, now let's say from here 1 to product, let's say product k is equal to 1 to 100, let's say product k is equal to 1 to 100, then you would have done this thing. समझ पा रहे हो ना? If the product is from, or let's say 2 to 100, let's say 2 to 100 k minus 1. 2 to 100 k minus 1 means, what is the meaning of this thing? 2 to 100 k minus 1, 2 minus 1, 1, 3 minus 1, 2, 4 minus 1, 3, and so on till 100 minus 1, which is 99. Now you do this indexing over here. So what will happen? Product of this will become k plus 1. You want to change this to k, let's say. So you are adding by plus 1. So if you're adding by plus 1, then what will happen is you have to decrease this by 1 unit. So k is equal to 1 to 99. This will become 99 over here. In this case, upper limit should be changed as well. Okay. So in this case, can you see you are getting the same thing? 1 into 2 into 3 and so on till 99. Got it or not? Yes. Then should we change both upper and lower limit? Definitely. Agar infinity is there, in that case you don't need to change, na? If infinity is there, in that case you don't need to change. Infinity minus 1. Infinity is a very large quantity. So infinity minus 1, what difference this will make? Hai na? You have to change. This is holding for summation as well. This will hold for summation as well. This has very nice applications in case of summations as well. Finite to I said to finite to you have to do it. This is very nice applications in case of summations as well. Summation ke liye bhi this will hold. Okay, summation for summation as well, this will hold. Summation of k plus 1. Okay, summation of k plus 1, k is equal to 1 to n, let's say 1 to 20, let's say. I'm taking smaller values, let's say. K is equal to summation k is equal to 1 to 20. What is it? Basically, you start putting the value 1 plus 1. या फिर 2 से start करो. Start from 2 itself. Summation k is equal to 2 to 20. So 2 plus 1, 3. 3 plus 1, 4. 4 plus 1, 5, and so on till 20 plus 1, which is 21. Now you do this indexing over here. So summation, you change this variable to k minus 1. Change this variable to k minus 1. So what happens over here? So this becomes k only. Yeah? So since you are decreasing over here, so you have to increase by this. You are decreasing by 1. So you have to increase by 1. So this will start from k is equal to 3 next. समझ पा रहे हो? K is equal to 3 to 20. Got it, got it, got it. So 23 plus 3 plus 4 plus and so on till, अच्छा 20, अच्छा 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 20 ना 20 ना 21 होगा. This will become 21 since you are increasing by 1. So 2 plus 1 3 and 20 plus 1 is 21. So 3 plus 4 plus and so on till 21. Simple thing. Only manipulating the summation. Is indexing clear to all of you? Yes or no? Anyways, chalo. So for this question, now here, like I said, here infinity is there, so infinity minus 1 will not make any difference over here because infinity is a very large quantity. Infinity minus 1 will still remain to be infinity only. Okay, so we are done with this. Next is this one. Acha, next is this one. Again, a very important manipulation you will see over here next. Okay. So we can use it for any natural number. Yes, 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 for any natural number. I'm not saying this thing for this thing. Let's say you are reducing by 2, let's say. If you are reducing by 2 also, let's say if product of k is equal to 4 to 10 is given. ठीक है, फिर k minus 2 is given. ठीक है. And let's say you are increasing by 2, let's say, to bring this in terms of k. Then what you have to do is you have to decrease by 2 over here. Decrease by 2 over here. Possible. Definitely possible. Hopefully indexing is clear to all. Okay, you can check both summation or both the products have the same meaning. After indexing, whether you are correct or not, you can verify by yourself. After indexing, whether you are correct or not, you can verify by yourself. Just break करके देख लो both the series. You take both the series and break from both point of view, and you will see you will get the same thing. Multiplied by, देखो product of. अच्छा, next is these two. Similarly, we'll do the same sort of indexing over here as well. So product of k is equal to 2 to infinity. Again, now this is a standard quantity. K square plus k plus 1 is a standard quantity. This is not a standard quantity. What we can do is, again, remember this thing. Again, a small simplification. Using a small simplification, we can bring this one into this form. We can bring this one into this form. Mane k square minus k plus 1 into this form. This is a very important simplification. देखो k square, ये ना k square minus k plus 1. If you replace k by k plus 1, if you replace k by k plus 1, you can easily bring into the form which is given in the numerator. Mane k plus 1 whole square minus k plus 1 plus 1. You simplify this thing, what will I get from here? K square plus 2k plus 1, and similarly minus of k minus of 1 plus 1. So minus 1 plus 1 cancels out. We are left out with k square. What is this? K square minus k, now plus k plus 1, which is the same thing which is given in the numerator. And this is a very important simplification. Do remember this thing, कि k square minus k plus 1 में, if you replace k by k plus 1, you will obtain k square plus k plus 1. K square plus k plus 1. This is a very important simplification actually. Take it? Got it? Got it? So what is the main thing? Basically, what we have done in the denominator, we are replacing k by k plus 1. है ना? We are replacing k by k plus 1. So, or in other words, can we say कि we are increasing k by 1 unit? Yes or no? Can we say this thing? We are increasing k by 1 unit. Yes or no? Mane basically we are doing this thing. We are replacing k by k plus 1. We are replacing k by k plus 1. Mane we are increasing k by 1 unit. Simple thing. We are increasing k by 1 unit. Now plus 1 tha na, minus k plus 1. We are increasing k by 1 unit. So we have to decrease k by 1 unit. So this will start from k is equal to 1 to infinity. And similarly, product of k is equal to 2 to infinity. This will remain as it is. We won't change this thing. This is a standard quantity. K square plus k plus 1 is basically loved by all students. K square plus k plus 1 is something which we face quite often, right? Okay, so we are done with this thing. Next is, acha, focus on this fraction part. This part, don't you think this part will become afterwards, after simplification? Let me do it somewhere else. Let me do it here. So don't you think this part, only this part I'm showing, this part will become product of something something. Okay, this part will become product of k is equal to 2 to infinity. This is k square plus k plus 1, or if divided by product of k is equal to 1 to infinity. Same thing, k square plus k plus 1. I have said after replacing k by k plus 1, you are getting the same thing. I have shown the proof over here. You will get back the same thing. You will get back k square plus k plus 1 only, right? And now over here, what you are left out with? You are left out with k is equal to 1 to infinity k, and this is product of k is equal to 3 to infinity k. Now you see the cancellations. Now it's easier for us to see the cancellations. Product of k is equal to 1 to infinity k is how much? 1 into 2 into 3 and so on up till infinity. Can I just break this numerator part? Can I break this numerator part as it's starting from 1, right? So I'm taking two values. So 1 times of 2 times of product of k is equal to 1 to infinity k divided by product of k is equal to 3 to k. K is equal to 3 to infinity k. Got my point? What I'm trying to do? I'm taking two values and I'm starting this from 3 once again, such that this quantity and this quantity will cancel out. Both have the same meaning. This will cancel out. And in a similar way, can we do the same thing for the remaining one? Dekho, this starts from 2 now, and this starts from 1. So I'm taking two values over here. This product starts from 2 and this product starts from 1. So product of k is equal to 2 to infinity k square plus, let this be as it is, and you start this from 1. You start this from 2 basically, not from 1. You start this from 2. You take one value, so 1 plus 1 square plus 1 plus 1, mane 3. Hai na? Are put the value of k is 1. So 1 square plus 1 plus 1, mane 3 only. So 3 multiplied by, then product starts from k is equal to 2. You have taken one value, so the next product will start from what? 2 only. K square plus k plus 1. So this quantity and this quantity will cancel out. So what is remaining? 1 into 2 divided by 3. Remaining part has cancelled out. 1 into 2 divided by 3. So mane 2 by 3. Answer is option B is correct. Again, I'm saying this is something, this question was directly given from sheet itself. Sheet towards the end, last minute I've just given some questions, list of some questions, standard questions based on series. This was the very first question from that particular list only. Before the exam, let's say 3 or 4 weeks before the exam, I've just given a list of series where this question was there. This was the very first question from the notes itself. I move on to the next question. We are done with the previous year questions of ISI 2025 limits. All 2025 questions are done. So we move to the next question. Next year, 2024 onwards. 2024. Now you will see that, you will get one question. So you can see over here in 2025, there were how many? 1, 2, 3, 4, 5 and 6. How many? 1, 2, 3, 4. 4 questions are there. 1, 2, 3, 4. 4 questions are there. 4 questions means 4 into 4, 16 marks were given for limits. Imagine. 16 marks were given from limits, out of which 3 questions were directly format based. Out of which 3 questions were directly based on formats only. Yeah, 3 questions were directly based on, the first 3 were based on formats. So 12 marks directly from format. And then the last question was a bit tricky. If you have done this question, also you will be able to solve this. Again, 16 marks were given from limits. Imagine. 16 marks from limits is a huge thing. From a single chapter, you're getting 16 marks. Now from 2024 onwards, you will see that questions are, questions, you will find one question, 2 questions, take a maximum 2 questions will be there. That is the usual format. I guess they have given so many questions on limit like in this year, but that is the usual format. You will be getting 1 questions, either 1 question, 2 questions, or no questions at all. You will be getting questions from continuity and differentiability. There you might have to use limits. Continuity and differentiability, there you have to use limits. You might have to use limits. Okay. Otherwise, you will see the direct limit questions are quite rare. Not kind of quite rare. Basically, you will find out 1 or 2 questions maximum. Let's say in 1 question in UGA or 1 question in UGB, like this, they can give. Okay. Okay, so I'm starting off with 2024's PYQs, and you will see that there is exactly 1 question from directly given from limits. There might be questions from continuity and differentiability. Like I said, I won't be taking those questions in this session. We will do this in the next session. So you can see here, this question is a direct question from UGB. So which means that there were no questions in UGA. So I've directly taken a UGB question. देखो, question says let px be a polynomial with real coefficients. Let a1, a2, a3 and so on till ak be distinct real roots of px is equal to 0. If p dash be the derivative of p, okay, p dash be the differentiation of p, show that for each I is equal to 1, 2, 3 and so on till k, limit x tending to alpha I, x minus alpha I, p dash divided by px is basically ri for some positive integer ri. Now, what are they trying to say basically? So px is, first of all, one by one, decode the lines. Px be a polynomial with real coefficients. Fine. A1, A2, A3 and so on till ak. So the basically ai are the distinct roots. Acha, this is not ai, this will be alpha I. This is alpha 1, alpha 2, alpha 3 and so on till alpha 3. This is given by x minus alpha I. So these are basically your roots. Alpha 1, alpha 2, alpha 3 and so on till alpha k are basically the roots. With the distinct real roots of px is equal to 0. So which clearly means if px will be, px is basically some polynomial. Px is some polynomial whose roots are given x minus alpha 1, x minus alpha 2. Maybe there is some leading coefficient. So I am taking a times of x minus alpha 1, x minus alpha 2, x minus alpha 3 and so on till x minus alpha k. Now the main thing is you need to understand over here that nowhere they have said that they have only said that these are the distinct real roots of px is equal to 0. Nowhere they have said that there are no other roots are there basically. Nowhere they have said that there are no more roots. These are the only roots. They haven't mentioned this thing. These are the only roots of the only distinct real roots of px is equal to 0. Okay. And these are the distinct real roots they have given over here. First of all, you don't know the degree of the polynomial. These roots can be repeating as well. These roots can be repeating as well. Okay. So the question is, p dash is the differentiation of p. So you have to show for each I is equal to 1, 2, 3 and so on till k, you have to find the value of this particular series. Okay, fine. Limit, not series, sorry, the limit. The value of this particular limit. Acha, main to hi funda hai ki a times of x minus alpha 1, we know these are the distinct real roots of px is equal to 0. Fine. They have only mentioned ki these are distinct real roots. They have mentioned that these are distinct real roots. Nowhere they have said that this is the only real root. So there can be one more factor as well, or one more factor, or two factors, or three factors. Okay. Maybe complex roots are there. Distinct real roots, they have said there can be other roots as well. Okay. So multiplied by gx. Also, these roots can be repeating as well. They have said distinct real roots of px. This is one more fact. If you haven't taken the they have said distinct real roots. The roots can be repeating as well. Some of the roots can be repeating. Some of them are not. You never know this thing. Some of the roots are repeating. They have, just look at the language over here. This is why I say solve the previous year questions. These are the distinct real roots of px is 0. Distinct real roots means the roots can be repeating also. Maybe or maybe not. Okay, maybe this root is repeating alpha 1 like this. So some of the roots over here, this is one very important thing which you need to consider, that these roots can be repeating. These roots, any of these can be repeating. Maybe or maybe not. I am not saying that this has to be repeating. They can repeat. So x minus alpha 1 raised to the power of p1, x minus alpha 2 raised to the power of p2 and so on till x minus alpha 3 raised to the power of p3 and so on till x minus alpha k raised to the power of pk multiplied by gx. Gx, why gx? Because you don't know that whether any other roots are present or not. Complex roots can be there. Okay. Next, what do we do is we'll simplify this thing, because we have to find the limiting value of this thing, x minus alpha x tending to alpha I, x minus alpha I, p dash of x divided by px ri. So in general, we have to find the value of this thing. So what will I do is I will simplify this thing as much as possible. Then I'll find out what is p dash of x divided by px. One thing you should note over here is basically this is something, this is a very common format which you people know. Actually, you have seen this format before. See, p dash of x divided by px. P dash of x divided by px. Okay, p dash of x divided by px. I hope you know this thing, that this is nothing but the d by dx of log of px. d by dx of log of px. Not difficult to prove. This is nothing but the d by dx of log of px. Obvious reasons, like d by dx of log of px is what? P dash of x, 1 by px, then multiplied by the differentiation of px, which is p dash of x. Okay. So why I'm giving this thing over here? Because you are having p dash of px, p dash x divided by px. You will be needing something like this. So can we just find the value of this thing? Definitely yes, but this is given in terms of product. So we need to simplify this thing by taking log on both the sides. So what I do is I'll take log on both the sides. Therefore, I'm taking log on both the sides. So once you take log on both the sides, acha, do one thing. Let us simplify this thing and write this thing as product of k is equal to 1 to, in a more compact form. Product of k is equal to, don't take k, we have used k over here, don't take k. Product of क्या बोलेंगे, product of I is equal to 1 to k. Product of I is equal to 1 to k, x minus alpha I raised to the power of pi, है ना? Product of I is equal to 1 to k, x minus alpha I raised to the power of pi, and then multiplied by gx. I'm writing this in a more compact form. Looks nice. ठीक है, done. So this is basically your compact form of px. Next, what I'm supposed to do is I'm taking log on both the sides. I'm taking log on both the sides, log of px. This becomes log of px. Fine. This will become log of px. Acha. Log of px. Now these are the product of three functions. So log of this will become log of a. This will become log of a plus log of this entire quantity. Log of this entire quantity. Don't you think this product will become summation? Yes or no? Don't you think the product will become summation? Yes or no? I is equal to 1 to k. Pi will come down. Pi will come down. Log of x minus alpha I will be remaining. Yes or no? Can you now visualize this thing, what I've tried to do over here? Yes or no? Plus log of gx. Plus log of gx. Simply taking log over here. Why do we take this thing? We need to simplify. We need to find the value of this. P dash of x divided by px. And now can you see over here, once you differentiate both the sides, this will become p dash of x divided by px. Alright, same thing. dy dx of log of px is what? P dash of x divided by px. 1 by px. 1 by px multiplied by differentiation of px, which is p dash of x. And log of a is just a constant, so this will become 0. Acha, what this will become? Let us see this thing. Acha, ye kar lete na. Let's do this thing first. Log of gx is there. Log of gx ka differentiation is g dash of x divided by gx. Plus, now this one. What do we do for this one? Pi is there. So pi is just a constant. So pi we can keep side, so that we are having log of x minus alpha I, and differentiation of log of x minus alpha I will be 1 by x minus alpha I. That's all. And summation will continue. Don't remove the summation, bhai. Summation will continue. Summation I is equal to 1 to k. Once you differentiate, summation will continue. This will become x minus alpha I. है ना? Every term, once you break this summation, don't you think that every term will have the same thing, like p1 log of x minus alpha 1, and so on. This will continue. Next term, second term kya hoga? Second term will be p2 log of x minus alpha 2, and so on. This will continue till pk log of x minus alpha k. This will continue, hai na? This is the last term. So once you differentiate all the terms, log of the first term, first wala log, second log, third log, and fourth log, all will have something like this: 1 by x minus alpha 1, 1 by x minus alpha 2, and so on. This will continue. So we are having this thing in a more compact form, writing this thing: summation I is equal to 1 to k pi upon x minus alpha I. Hopefully this much is clear to all. Clear hai ki nahi? Clear or not clear? Okay. So now what do we have to find is we have to find the value of x minus alpha I, limit extending to alpha I, x minus alpha I p dash of x divided by px. Simple, eh? So let us find out this value next. So we have x minus alpha I p dash of x divided by px. Okay. Similarly, x minus alpha I p dash of x divided by px. G dash of x divided by gx. Plus x minus alpha I summation. Acha, one more thing. See over here. Here, x minus alpha I, which you have taken over here. One more thing, certain conditions which I haven't mentioned over here. Here, gx is there. Now, be very careful over here. Certain conditions which I haven't mentioned over here. I forgot to mention the conditions here. Look at this thing. G of alpha I will not be 0. G of alpha I won't be 0. Because alpha i's are basically the roots of this factor, na? Alpha i's are consumed by this. Alpha i's are consumed by this. Alpha i's won't be consumed by gx. Gx is different thing. I said that if any other roots are there, then we are taking gx over there. Okay? So g of alpha I won't be 0. This is what you need to understand over here. Got it? One more condition. One more condition you should mention over here is basically the PIs. All PIs are basically natural numbers. PIs are basically what the repeating thing, na? The number of terms, number of values they are repeating. So PIs will be natural numbers. You multiply with x minus alpha I over here, because that's what we need to find out. X minus alpha I p dash of x divided by px. Okay, and g dash of x divided by gx, then multiplied by x minus alpha I. And plus similarly x minus alpha I. Now see, x minus alpha I, one of the factors will cancel out. One of the factors cancels out. So one of the factors cancels out means alpha I, only pi will remain. Only one of the value, this will take, at some point of value, this will take the value and one of the value will cancel out. Only pi will remain. Okay, and then the remaining values will be going from j is equal to 1 to k. J is equal to 1 to k. P of I divided by P of I divided by P of j divided by x minus alpha j. P of j divided by x minus alpha j multiplied by x minus alpha I. What we have done over here, देखो, very carefully, once again I'm showing you. Very carefully, please see what I have done over here. Very carefully, again I'm showing you what I have done. Why this is becoming pi, why this is taking one of the value. Let's say if I is 7 tomorrow. Let's say I is 7 tomorrow. So what will happen is x minus alpha 7 will be there. X minus alpha 7 into g dash of x divided by gx. Look at the right hand side, just the right hand side I'm saying. Plus what will happen? One of the term will cancel out. One of the term will cancel out. One of the term. Which term will cancel out? X minus alpha 7 will cancel out. Rest won't cancel out. Rest won't cancel out. You are taking alpha 7 over here. So x minus alpha 7 will cancel out. Only the 7th term will cancel out and P7 will be remaining. P7 is remaining. ठीक है ना? Only the 7th term, अरे x minus alpha 7, x minus P7 divided by x minus alpha 7. This is x minus alpha 7. This will cancel out. This term and this term will cancel out. Only P7 will be remaining. What about the remaining terms? As it is. As it is, the remaining terms going from except 7. Except 7, P, the remaining term will be, next will be going from Pj divided by x minus alpha j. ठीक है, pj divided by x minus alpha j. The remaining terms will be going from summation j is equal to 1 to k, where j won't be 7. J won't be 7 next, because j7 to gone. That term has been taken and that has been cancelled out. Got it? Got it? Now is this concept clear to all? देखो भाई. So now next you can take the limits over here. Next you can take the limits. So what is remaining? Pi will be remaining, and then the remaining terms. Remaining terms going from j is equal to 1 to k, but here j won't be I because I has been taken. One of the value is gone. So j is not equal to I. So next you can just directly plug in the limits. So limit extending to alpha I. Taking limits on both the sides. Limit extending to alpha I. Limit extending to alpha I. Similarly here also, limit extending to alpha I. What is the difference over here? Now see, the right hand side will become limit as x tends to alpha I. G dash of alpha I divided by g of alpha I. G of alpha I is not 0, we have taken. G of alpha I is not 0 because alpha i's are consumed over here. Alpha I is not the root of this. So g of alpha I is not 0. Okay? So definitely this quantity will tend to 0. because of this quantity x minus alpha I. So as x tends to alpha I minus alpha I will tend to 0. This will tend to 0. Now this is just pi only. So it's 0 plus pi. This is just pi only. It is independent of alpha I. X basically. It is independent of x. So this will be straight away pi plus. Next क्या होगा? Next will become summation j is equal to 1 to k. J is not equal to I. Pj divided by x minus alpha j into x minus alpha I. Directly plug in the limits. So we are having summation j is equal to 1 to k where j is not equal to I. For pj divided by, देखो pj divided by pj into x minus alpha I divided by alpha I minus alpha j. Alpha I minus alpha j is non-zero. Alpha I minus alpha j is non-zero, not equal to 0. These are distinct roots. Alpha I and alpha j are distinct roots. All are distinct roots actually. So this cannot be 0. Okay. So this quantity is non-zero, but in the numerator we are having alpha I minus alpha I. So this will become 0. So this quantity will also tend to 0. This will become 0. So 0 plus pi. 0 plus pi plus 0. This will be pi only. So this is your final answer. The limiting value will be pi. This value will be pi. Pi means, what is the meaning of pi? The value will be exactly the same as the roots which are repeating. One of the powers. The value will be exactly the same as the roots repeating. ठीक है? So PIs are what? The number of times the roots are repeating. ये है ना powers. That is basically your PI. So RI is the same as PI. They are saying कि for some positive integer RI, you show that this limit will be equal to RI. ठीक है? तो PI and RI have the same meaning. ठीक है? So here PI is, final statement will be, here PI is the same as RI. Here PI is the same as RI for all I is equal to 1 to k. Did you all get this question? Yes or no? Chal, next. ISI 2023 PYQs. 24 done, 23. Chalo. 23 PYQs. Okay, so we have this question next. Limit extending to 0, 1 by x, cos x plus cos 1 by x minus cos x into cos 1 by x minus 1. Again, this is clearly a format based question. I have said this thing, whenever A, B and 1 is present, always factorize. A, B and 1 is present, always you will factorize. Clear? So you are having the same thing. A plus B, A plus B, you are having A plus B minus of AB minus of 1. A, B and 1. It's a format actually. It's a profile of question which is taught under limits. So whenever these terms are there, always factorize and then proceed. So factorize this thing. What is this? Basically A plus B minus AB minus 1. How do you factorize this thing? Very simple to factorize. So basically from here, from these two terms, you take out A common. So we are getting 1 minus B. And from these two terms, B minus 1 say, you will take out minus 1 common. So we are having 1 minus B. Right? So what is it? A minus 1 times of 1 minus B. Okay. And what is A now? A is basically cos x and B is cos 1 upon x. So this is limit extending to 0. Limit extending to 0. So 1 by x times of this simply gets reduced to A minus 1, which is cos x minus 1. Cos x minus 1 into 1 minus cos 1 by x. Okay. Again, so what we can do is we can take out a minus sign common and we can solve this thing. Just take out a minus sign common. You will ask the question, sir, why do we just need to take a minus sign common? By minus of 1 minus cos x divided by x square, let's say. I'm taking x square. One extra x also I'm taking over here. So you have to multiply by x over here. So why are we doing this thing? Format. Format is known to us. 1 minus cos x upon x square. And this is x into 1 minus 1 upon cos 1 upon x. What is this basically? Half standard limit. Limit extending to 0. 1 minus cos x upon x square is basically what? Half. This will tend to half. And once you distribute the limit over here, this is x tends to 0. So 0 multiplied by, this will become 0 multiplied by 1 minus cos of some oscillating number from minus 1 to 1. Cos 1 by 0. Cos 1 by 0 is any quantity, some oscillating number from -1 to 1. Oscillating number from -1 to 1. This can be any number from -1 to 1. So 1 minus any number from -1 to 1 will give you a finite quantity. 1 minus, this is a finite quantity from -1 to 1. So 1 minus finite quantity is what? Finite quantity. So 0 times of any finite quantity will be 0 only. This will be 0 only. And 0 multiplied by, so it's technically minus half multiplied by 0. Minus half multiplied by 0, which is ultimately 0 only. So option A is correct. These are clearly format-based questions. A, B, and 1. If these 4 terms are present, obviously you will go for factorization. I do mention all these things in my limit classes. Whenever you're having these kind of formats present, you have to factorize this thing. Next question. Next question says the limit n tends to infinity, 2 to the power of minus 2 to the power of n plus 1 plus 2 to the power of minus 2 to the power of n minus 1. Again, whole raised to the power of 2 raised to the power of minus n. So many 2 raised to the power of n's are there. So it's better, I think it's better to first reduce this as much as possible. It's better to first reduce this as much as possible. So limit n tends to infinity. Therefore, limit n tends to infinity. This is 2 to the power of minus 2. Therefore, this is 2 raised to the power of minus 2 raised to the power of n and plus 1. So which is the same thing as minus 2 raised to the power of n into 2 raised to the power of 1. Bring this down. So it's minus 2 raised to the power of n into 2. And similarly, we have 2 raised to the power of minus 2 raised to the power of n. Again, minus of 2 raised to the power of n. Here minus 1, but multiplied by 2 raised to the power of minus 1. So divided by 2. Then whole raised to the power of 2 to the power of minus n. So many 2 raised to the power of n's are present. So best thing is to, take 2 raised to the power of n as t and then solve. Obvious reasons. If too many variables are present over here, so convert this thing, substitute something and then simply solve. This will be easier for you to solve. 2 raised to the power of n as t. So as n tends to infinity, t also tends to infinity. T will also tend to infinity. So now your new limit will be from t tends to infinity. So 2 to the power of, it's basically 2 to the power of minus 2t, minus 2t, minus of 2t, minus of 2t plus 2 to the power of minus of t by 2, minus of t by 2, whole raised to the power of 1 by t, whole raised to the power of 1 by t, and this is one form which we are getting. You can check over here that this is still a standard form. You can see over here as t tends to infinity, this will tend to 0, this will tend to 0, and this is 1 by infinity will also tend to 0, which is 0 raised to the power of 0. This is 0 raised to the power of 0. 0 raised to the power of 0. Okay, 0 raised to the power of 0, but this can be easily solved. You don't need to take log over here, because you can definitely solve log. You can definitely take log and solve over here, but let us solve this in a more smarter way. Smarter way, mane, suppose you are having also, remember this thing, limit is, why I am using this smarter way over here, because limit is tending to infinity. So you can think of, solving this by some smarter way and not by taking some log over here. Okay. Because of this, limit t tends to infinity. Why? Because see, you take out the larger quantity common. Take out the larger quantity. You can take log. You can definitely take log and solve this thing, but log will take some more time. Thoda smarter way se solve karo. Basically, what you do is you take out 2 to the power of minus t by 2 common, whichever is the bigger quantity. Which is the bigger quantity? 2 raised to the power of minus t by 2. As t tends to infinity, 2 raised to the power of minus t by 2 is the bigger quantity. So you take this out common. So 2 raised to the power of minus t by 2 comes out. ठीक है, और फिर whole raised to the power of 1 by t भी था, तो whole raised to the power of 1 by t means multiplied by 1 by t. This will come out, right? And what is remaining over here? What is remaining here? Limit t tends to, limit to will continue, limit t tends to infinity. What is remaining inside the brackets? 2 raised to the power of minus of 2t. How much you have taken common? 2 raised to the power of minus t by 2. So you will divide by 2 raised to the power of minus t by 2. And so once you take this in the numerator, so 2 raised to the power of minus 2 will become plus t by 2. So this will become plus t by 2. ठीक, और फिर plus 1 whole raised to the power of 1 by t. So what is the benefits? This will become t and t cancels out. So we are having 2 raised to the power of minus half. Okay, now see the form is kind of gone. Here this will become 2 raised to the power of minus 2t plus t by 2, which is 2 raised to the power of minus 3 by 2t. Minus t by 2t plus 1. Hopefully I'm correct. Minus 4t plus t. So minus t by 2t plus 1 whole raised to the power of 1 by t. And limit t tends to infinity. This is just a constant now, and the form is gone, you can see. So 2 raised to the power of minus half is just a constant, so you can take it out. And we are left out with t tends to infinity. Now you can directly plug in the value over here. See, you can directly plug in the value. So as t tends to infinity, you can clearly see that this will tend to 0. So 0 plus 1 is 1. So 1 raised to the power of 0. ठीक है ना? You people can see from here. So 1 or फिर 1 raised to the power of 0, which is 1 only. So is the answer 2 raised to the power of minus half. 2 raised to the power of minus half. So माने 1 by root 2. 2 raised to the power of minus half माने 1 by root 2. So answer must be option B must be correct. 1 by root 2. So how to know which one is the largest quantity? How do you know that it is the largest quantity? अरे भाई देखो, simple thing कि 2t. First of all, तो you people know this thing कि t 2t is basically more than t by 2. 2t is more than t by 2 ना? तो minus of 2t is what? Less than minus t by 2. So 2 raised to the power of minus 2t is less than 2 raised to the power of minus t by 2. So which one is bigger? This quantity is bigger, na? This quantity is bigger quantity. So as t tends to infinity, 2 to the power of minus t by 2 is a bigger quantity as compared to 2 raised to the power of minus 2t. ठीक है? So I'm taking out the bigger quantity. In fact, that's what we do in case of limit questions, that we take out the value which is a bigger quantity. In case, if let's say if x tends to infinity or t tends to infinity, we all simply take out the bigger quantity common and then we solve. Bigger quantity common, or whichever quantity is tending to infinity. The larger quantity which is tending to infinity, we take out as common, we divide it and then we solve. This will be easier for us. Look at the next question. Next question says a naught is half. A we define inductively by this quantity. An is square root of 1 plus an minus 1 divided by 2. So some recurrence is given, and whenever recurrence is given, and also they have said ki show for n is equal to 0, 1, 2, 3 and so on, an is cos theta n, where theta n lies in between 0 and pi by 2. So I have said this thing ki whenever recurrence is given, always this is our tendency ki whatever they are asking you to prove, तो ये एक हैबिट होता है कि बेसिकली द क्वेश्चन माइट बी, लगेगा आपको कि दिस क्वेश्चन इज बेसिकली दिस माइट बी अ क्वेश्चन फ्रॉम इंडक्शन. So the proof must be done using induction whenever these kind of recurrences are given and you have to find out an or something. Okay, so mostly the proof is basically done using, in most of the cases, the proofs are basically done using induction only. ठीक है? The same thing holds for questions based on increasing sequence and decreasing sequences. Most of the questions are based on induction only. ठीक है? So basically we need to show that an जो sequence है, an sequence is given by cos of theta n, and also we have to determine theta n as well. Okay, we also have to find the value of theta n, for which theta n lies in between 0 and pi by 2. So basically we have to convert all the things in terms of cos. We have to convert all the things in terms of cot to find out an, to prove that an is cos of theta n. They have mentioned this thing, an is cos of theta n, which means each of these terms has to be related in terms of cos theta. Each of these terms, a naught is half. Half is what? Half is basically cos of pi by 3. So you have to relate each of these terms in terms of cos of theta. Okay? And there, using induction, you have to generalize this thing and prove that an is cos of theta n. And also you have to find out theta n as well. Okay? So I've given the solution over here. You can see that first what I have done is I have taken a naught to be as half, which is cos of pi by 3, so which is the same as cos of theta n. Theta naught, I am taking this for the first time, I am taking this value as cos of theta naught given, where theta naught is pi by 3. Where theta naught is pi by 3, and theta naught definitely lies in between 0 and pi by 3. Pi by 2, but this will be from 0 and pi by 2. Theta naught lies in between 0 and pi by 2. Okay, because they have said this thing, theta n, for whatever values of theta n, where n goes from 0 to 1 to 1, 2, 3 and so on, theta n must lie in between 0 and pi by 2. So here n is 0, which means theta naught, which is pi by 3, lies in between 0 and pi by 2, satisfied. The first one is verified. Next, again, we'll check for A1. We'll check for A1. What is A1? The first step. First step of induction is basically we'll check for A1. What is A1 given? Square root of 1 plus A naught divided by 2. From this recurrence, basically, you just simply plug in the value of n to be 1. So we'll get A1 is square root of 1 plus A1 minus 1, which is A naught divided by 2. Which is the same thing as square root of 1 plus cos of theta naught divided by 2. Okay, so 1 plus cos of theta naught is, once again, you can simplify this thing. What is it? 2 cos square theta naught divided by 2. 1 plus cos theta, basic formula of trigonometry is being used. 1 plus cos theta is 2 cos square theta. So 1 plus cos square theta naught will be 2 cos square theta naught divided by 2. Okay. 1 plus cos 2 theta, sorry, 1 plus cos 2 theta will be 2 cos square theta. So 1 plus cos theta, 1 plus cos theta will be exactly half of this angle will take place over here. So 1 plus cos theta will be 2 cos square theta upon 2, exactly half of this angle, Okay, so 2 cos square theta naught divided by 2, and 2 cancels out. So what is remaining? Cos of theta naught divided by 2. Okay, cos of theta naught divided by 2, and I'm giving this some new name over here, which is cos of theta 1. I'm giving this theta naught divided by 2 as theta 1. Now you see over here, theta 1 is theta naught divided by 2. Theta naught lies in between 0 and pi by 2. Okay, theta naught lies in between 0 and pi by 2. Over here you can see from here, देखो theta naught जो है, theta naught lies in between 0 and pi by 2. We have seen theta naught lies in between 0 and pi by 2. Okay, अच्छा, तो theta 1 is what? Theta naught divided by 2. So theta naught divided by 2 will lie in between 0 and pi by 4. Okay, pi by 4 is basically 45 degrees. So which is definitely less than pi by 2. Pi by 4 is 45 degrees, so which is definitely less than pi by 2. So theta naught by 2 also lies in between pi by 2, 0 and pi by 2. Theta naught by 2 also lies in between 0 and pi by 2, and hence theta 1 also lies in between 0 and pi by 2, which we are proving from here itself. Clear? We are proving from here itself. Got it? Got it? Here I have done a slight mistake over here. This will be theta naught lies in between 0 and pi by 3. This won't be pi by 3. This will be pi by 2. This will be pi by 2. So theta naught lies in between 0 and pi by 2. So theta naught by 2 will lie in between 0 and pi by 4. This will be pi by 4, and pi by 4 is less than pi by 2. So theta 1 lies in between 0 and pi by 2, the one which I've just done right now. So theta 1 also lies in between 0 and pi by 2. Okay, so we have checked for the first value. So next is for the induction hypothesis step. So the second step is basically you assume this the same thing for, let this be true for n number of values. So an is cos of theta n for some theta n lies in between 0 and pi by 2. Okay, let this be true. An is cos of theta n. And then the third one is basically your inductive step, which you prove for n plus 1. So then you check for n plus 1. So n plus 1 will be square root of 1 plus an divided by 2, which is 1 plus cos of theta n. What is an? An is basically, I have taken from the first step, from the second step, basically from the induction hypothesis step, I have taken an to be cos of theta n. Okay, what is this? Basically, we are assuming this. Let an is cos of theta n for some theta n lying in between 0 and pi by 2. Okay, using this, we will prove the third step. That's what we do in case of inductions, right? So here an plus 1 will be, for an plus 1, this will be square root of 1 plus an divided by 2. Again, 1 plus square root of 1 plus cos of theta n divided by 2. And again, once again, you simplify this thing. So this will become square root of 2 cos square theta n divided by 2 divided by 2. 2 and 2 cancels out. You will be having cos of theta n divided by 2. So for an plus 1, we are having cos of theta n divided by 2. Again, for representation, I am writing this as cos of theta n plus 1. I am writing this as cos of theta n plus 1. So theta n plus 1 will be theta n divided by 2, where theta n plus 1 also lies in between 0 and pi by 2. And you can check this thing. Theta n plus 1 lies in between 0 and pi by 2. Theta n, so देखो ये जो theta n है, theta n divided by 2 lies in between. From the second step, we have just proved that theta n lies in between 0 and pi by 2. From the second step, we have proved this thing. Theta n lies in between 0 and pi by 2. So theta n by 2, once again the same thing. Theta n by 2 lies in between 0 and pi by 4, which is definitely less than pi by 2. So theta n by 2, which means theta n plus 1 also lies in between 0 and pi by 2. We have proved this thing. Okay? So theta n plus 1. So we have just proved that an plus 1 will be cos of theta n plus 1. Okay, an plus 1 is just cos of theta n plus 1. So induction is verified over here. The principle of mathematical induction is verified over here. The only thing which is left out is you just need to find the value of theta n from here. Find the value of theta n from here. Okay, the same thing what I've done over here. Cos of theta n plus 1, and where theta n plus 1, the same thing which I've done over here. You can see theta n lies in between 0 and pi by 2. Theta n by 2 lies in between 0 and pi by 4. So theta n plus 1 also lies in between 0 and pi by 2 only. The same thing which I just did over here. Now the thing is, your main task is to find out theta n, no? Your main task is to find out theta n. So once you find out theta n, so you're done. So theta 1 is now, see the pattern from here. So you have just found out देखो θ1, first you have found out θ0. θ0 was this thing. Then you are finding out a1. a1 is basically, for a1 you are proving for cos of θ1. θ1 is what? Theta this. The main condition starts from here. θ1 is θ0 by 2, right? θ1 will be θ0 by 2. Similarly, next step में θ0 कहाँ गया ये? Then you are deducing that an plus 1 is cos of theta n plus 1. माने theta n plus 1 is theta n divided by 2. You are finding this recurrence. One more thing from here. You are finding that theta n plus 1 is theta n divided by 2. Okay. You can check for a2 as well. If you are having any kind of doubt, you can check for some more values. Let's say for a2 as well, you can check. a2 will be what? Square root of 1 plus a1. a1 divided by 2, and just simply plug in the values over here and you will check. And you will check from here. You will get theta n by 2 only. ठीक है? Anyways, so the thing is, you are getting some relation from here only. Theta n plus 1 is theta n divided by 2, right? So theta naught, you can see from here. देखो, theta 1 is theta naught divided by 2. I've given it over here. See, theta 1 is theta naught divided by 2. Then second time, theta 2 will be theta 1 divided by 2. है ना? अरे theta n plus 1 is basically theta n divided by 2 ना. So theta 2 is what? Theta 1 divided by 2. Again, we know the value of theta 1, which is theta naught divided by 2. So theta naught divided by 2, which is theta naught divided by 2 square. And then theta 3 will be what? Theta naught divided by 2 cube and so on. This will continue. And theta n will be what? Theta naught divided by 2 raised to the power of n. This will continue in this sense. Okay. So theta n is what? Theta naught divided by 2 raised to the power of n. And what is theta naught? Now we know what is theta naught. What is theta naught? Pi by 3, which we have taken initially, which we have taken. Okay. So your theta n is what? Theta n will be pi upon 3 times of 2 raised to the power of n. So once you have obtained theta n, so you just find out what is an. What is an? An will be cos of pi upon 3 times of 2 raised to the power of n. Now in part B, they are asking you to calculate this limit. Limit n tends to infinity. What they have asked to calculate? Limit n tends to infinity. 4 to the power of n times of 1 minus an. So 4 to the power of n times of 1 minus an. So 1 minus an means this only. Cos of pi by 3 times of 2 raised to the power of n. So once you have found out what is theta n, once you have found out what is an, so it's not difficult to find out what is this quantity. So 4 to the power of n, limit n tends to infinity, 4 to the power of n. What do we do over here? Let's bring this 4 raised to the power of n down. What's it? Let's bring this 4 raised to the power of n down. So cos of pi upon 3 times of 2 raised to the power of n. This is 4 raised to the power of n. I'll bring this 4 raised to the power of n down. 1 minus cos theta divided by theta square. That's what we do, right? 1 minus cos x divided by x square, right? So don't you think that we are having, this is the same thing as 1 by 4n. 1 by 4 raised to the power of n is the same as 1 by 2 raised to the power of n the whole square. Okay? 1 by 2 raised to the power of n the whole square. So we are having a similar kind of thing, but we are not getting the same quantity. So let's bring this into that same format. Let's bring this into the same format. What is missing? What is missing? Pi is missing. And pi is missing and 3 is missing. So pi by 3 is missing. And pi square and 3 square. Yes or no? Don't take pi square and 3 square because we are taking whole square over here. So pi and 3 is missing over here. So how much extra we are taking? How much extra we are taking? We are taking 3 by pi whole square extra. Okay? We are taking 3 by pi whole square extra. Pi by 3, cancel out this by taking 3 by pi whole square. है ना? अरे pi square and pi square. So multiply by pi square, divide by pi square. Multiply by 3 square, divide by 3 square. Simple thing. है ना? Why are we doing this thing? अरे this format. 1 minus cos x divided by x square and limit extending to 0. This is basically half. But sir, this will only work if x tends to 0. And this same by same quantity is there. Same by same, though we have brought. We have brought in terms of same by same. Same by same square. And x tends to 0. Now, is this quantity tending to 0? Definitely yes. As n tends to infinity, pi by 3 raised to the power of 2 to the power of n will tend to 0. Pi by infinity will tend to 0. So this quantity tends to 0. So yes, this format will work out over here. Right? So this quantity will become half. So basically you are having half times of pi square by 9. So your answer must be pi square by 18. Limit is easy to calculate once you have got theta. Next, we move on to 2022 PYQs. Okay, direct UGB question I've given. So Px is given to be 1 plus 2x plus 7x square plus 13x cube. So some polynomial is given, x belongs to all real numbers. Calculate for all x belongs to R, limit n tends to infinity p of x upon n. This is a very simple question. Like 2022's question paper, if you know 2022's question paper is considered to be one of the most easiest question papers in the history of ISI. So this was quite straightforward question. Okay. And you can clearly see once you just find out this thing p of x by n. What is p of x by n? So basically they are asking you to find out what is limit n tends to infinity. Limit n tends to infinity p of x by n. So p of x is given. So find what is p of x by n. So this will be 1 plus 2 times of x by n and a plus 7 times of x by n whole square plus 13 times of x by n whole cube, right? And this raised to the power of n. That's what we are having. So now once you check the form over here, a very straightforward question. You can check the form directly over here. Here x belongs to all real numbers, right? So all real numbers divided by tending to infinity. Some real number divided by tending to infinity will tend to 0. All these quantities will tend to 0. All these quantities will tend to 0. You are left out with 1 raised to the power of infinity. This is of the form 1 raised to the power of infinity. Formula is known to us. E raised to the power of, what is it? E raised to the power of limit n tends to infinity. So this power will come down. Gx times of fx minus 1. Yeah, gx will come down. Fx minus 1. So fx minus 1 means this minus 1. Acha, so 1 plus 2 times of x by n. This quantity 7 times of x by n whole square plus 13 times of x by n whole cube. और फिर minus of 1. ठीक है, तो 1 and 1 cancels out. So as n tends to infinity, all these will tend to 0. And ये भी लिख लो, e raised to the power of limit n tends to multiply this thing. So e raised to the power of limit n tends to infinity. You can see over here, once you multiply this thing, this will cancel out. All these will cancel out. One of the n will cancel out over here. And one of the n will cancel out. So what is remaining over here is 2x. 2x बचेगा. What is remaining? 2x is remaining. 2x plus 7x square divided by n. 7x square divided by n, one of the n is cancelled out, plus 13x cube. 13x cube divided by n square. This is what we are having. And once you plug in the limits, as limit n tends to infinity, this will tend to 0 and this will also tend to 0. Okay, so what is remaining? 2x is remaining. And 2x is what? Independent of n. So e raised to the power of 2x is basically your answer. E raised to the power of 2x. Now the thing is, this question was given for 10 marks. This question was given for 10 marks. And if you just do this much calculation, then hopefully, most likely you won't be getting full marks. Most likely you will be getting somewhere around 4 or 5 or something. So how to get the full marks? Show the proof of e raised to the power of this thing. Show the proof of 1 raised to the power of infinity, this formula. Show the proof of this formula, e raised to the power of limit n tends to a, x tends to a. Whenever you are having this thing, 1 raised to the power of infinity, fx raised to the power of gx. Enough? What is it? Basically, limit x tending to a. Fx raised to the power of gx is e raised to the power of limit x tending to a. Gx comes down, fx minus 1. You have to show the proof of this formula. So whenever this question is such simple and they are giving this kind of simple question in your UGB, so most likely you won't be getting full marks for this much workings. At least you have to show the proof of this formula. The proof is a very standard proof. Hopefully you will know this proof actually. Okay? Any standard book you will find out this proof is given. And I have discussed this in my lectures also. So this is not new to you. Let's move on to ISI 2021 PYQs. ISI 2021 PYQs. Okay, this is a very nice question on polynomials actually. ये तो limits है ना. This is a very basic kind of limits they have given. The main concept is basically you need to figure out what is the polynomial px. Therefore, let a0, a1, a2 and so on till a19 belongs to all real numbers and px is given to be this polynomial x to the power of 20 plus summation I is equal to 0 to 19 ai x to the power of I. And one condition is given, px is p of minus x for all x belongs to R, and p of k is basically k square. For k is equal to 0, 1, 2, 3, and so on till 9, we have to find this limit actually. So forget about this limit. The main question is you have to figure out this polynomial px. Okay, because the limit is very easy. Once you figure out the polynomial px, so you're done. So using these conditions, you need to figure out the polynomial px. So first is you should be able to explicitly write down the polynomial. This is a simple question. Only, you need to manipulate this thing very carefully. So px is x to the power of 20 plus summation ai x to the power of I. So what is the meaning of this thing? You first write down the polynomial in the clear-cut form, basically what we know actually. So what is it? Px will be x to the power of 20 plus summation of this thing. Now x to the power of 20 summation of a 19. I'm starting with 19. I'm starting with the last term. So why with the last term? Because let's say 20, 19, it looks better. Take it. A 19, x to the power of 19, a 18, x to the power of 18, and so on. Till 0, which is a not actually. This will go in this sense. Here the AIs are all belonging to real numbers. All the AIs will belong to real numbers. Okay, px is basically p of minus x. Now we will use this condition. P of x is p of minus x and p of k is k square. Two conditions are given one by one. We have to use all of them. Where we have to use, let's use the first condition. P of x is p of minus x. So I have the workings. Let's not waste time. I've given the solution over here. See over here. देखो px is this polynomial which I have given. Px is x to the power of 20 plus a 19 x to the power of 19 plus a 18 x to the power of 18 and so on till a1x plus a0, like the way I have just said. Okay. Now what they have given, p of x is p of minus x. So just simply use this thing, p of x is p of minus x. What will I get from here? X to the power of 20. Write down px, simply equate p of x and p of minus x. You replace x by minus x, you will get p of minus x. So x to the power of 20 plus a 19, x to the power of 19 and so on. And similarly on the right hand side, we will be having x to the power of 20 minus a minus plus minus plus, this will continue. Take a same thing with minus plus plus minus plus minus, this will continue. Take it. And once you compare the coefficients over here, you will see that the odd coefficients will be 0. Once you compare the coefficients over here, you can clearly see that basically this polynomial is true for all real numbers, no? This polynomial is true. This thing is true for all x belongs to R. This is true for all x belongs to R. So this will cancel out. We can cancel out kind of thing. So this will cancel out. Yeah, this will cancel out. Similarly, all the remaining terms will cancel out. So what is remaining? A19 x to the power of 19. Similarly, minus of a19 x raised to the power of 19. You bring this on the left hand side, you will be getting 2 times of a19. Hai na? And all coefficients, the odd coefficients, just compare the coefficients over here. Just compare the coefficients over here. A19 and here we are having minus of a19. A19 and here we are having minus of a19. Okay, so this is 2 times of a19 will be 0, which means a19 is 0. So similarly, all the odd coefficients will be similarly equal to 0. So finally, we are getting a2k minus 1 is 0, which is the sum of the all odd coefficients because it's starting from a1. No? So a2k minus 1. A2k minus 1 for all k is equal to 1, 2, 3 and so on till 10. Okay? This is basically what we are getting over here. Chalega. Why till 10 we have taken? See, 2 into 10 minus 1, which is 90. 90 terms are there. 1, 3, likewise 1, 3, 5 and so on till 90. 1, 3, 5 and so on till 90. So k is equal to 1, 2, 3, so on till 10. 10 values are there actually for 2k minus 1. Okay, 10 values of k are possible. Fine. Done with this. So one conclusion we are getting, that is a 2k minus 1 is equal to 0. A 2k minus 1 is equal to 0 is one conclusion which we are obtaining from here. Clear? Achha. Next we are using this condition. See, once again, one condition is given. Which condition? P of k is k square. This condition is given. P of k is k square. For k is equal to 0, 1, 2, 3 and so on till 9. Okay? P of k is k square. So if P of k is k square, from using this thing, we get P of 0 is 0. P of k is k square. So P of 0 is 0, which means A0 is 0. So one more value we are finding. Here, one more value we are finding, which is A0. A0 is 0. So we can now reduce the polynomial in terms of, we have the new polynomial. New polynomial will be, Px will be x to the power of 20 plus A18 x to the power of 18 plus A16 x to the power of 16, sorry. And so on till a2x square. This is our new polynomial. Hopefully this much is clear to you. Are A0 will be 0 na? A0 will be 0. This quantity is 0. Odd coefficients are also 0. Yes or no? Array A0 is 0. Odd coefficients are also 0. So what is remaining? Even coefficients, even terms are remaining. X to the power of 20 plus A 18, 20, 18, 16. All these are remaining actually. And one more thing is leading coefficient is 1 over here. One more thing to say. Leading coefficient is 1, which means this is a monic polynomial. Leading coefficient is 1, which means Px is a monic polynomial. Fine. I hope this much is clear to all. So what we have derived actually, so we have derived that coefficients, odd coefficients are 0. A0 is 0. Okay, the constant term which is remaining, that is 0 actually. So this is what we are having. Px is this polynomial. Okay. Now again we are using this condition. P of k is k square. What they have given? P of k is k square. Ithana, P of k is k square. Again we are using this condition. P of k is k square. Be very careful. P of k is k square for k is equal to 0, 1, 2, 3 and so on till 9. Okay, so it's taking 10 values. For 10 values, P of k is k square. So see over here. So, देखो, P of k is k square for k is equal to 0, 1, 2, 3 and so on till 9. Again, we are using P of k is k square wala condition. Acha, P of k is k square you see in this manner. P of k is k square or Px minus, I have said this thing. You see this in this manner. P of x minus x square is equal to 0. Okay, this is an equation whose roots are what? X is 0, 1, 2, 3 and so on till 9. You see in this way. Okay. What are we trying to do? What are we trying to do? We are trying to find out Px. We are simply trying to find out Px, nothing else. So Px minus x square is 0 for x going from 0, 1, 2, 3. In the place of k, I am writing simply Px minus x square. This looks decent, na? Polynomial hai. So Px minus x square. Acha, Px is of degree 20. Px का जो degree है, Px is of degree 20. Be very careful. Degree of Px is 20. ठीक है? Degree of Px is 20. So Px minus x square is 0 for x 0, 1, 2, 3 and so on till 9. So what is the meaning of this thing? Can I say that Px minus x square? Can we write down Px minus x square as x into x minus, माने x minus 0 multiplied by x minus 1 multiplied by x minus 2 and so on till x minus 9. Can we say this thing? Yes or no? ठीक है? Can we say this thing? Also, Px is what? A monic polynomial. And we are subtracting minus x square. Listen, we are subtracting minus x square. Px is what? A monic polynomial. We are subtracting minus x square. So what are the changes over here? Coefficient won't change. Only this term will change. Leading coefficient won't change. We are subtracting minus x square only. Leading coefficient won't change. Only this term will change. So degree won't be affected at all. So this polynomial is still of degree what? 20. This is still of degree 20. But these are 10 factors. So one more factor is needed. Getting my point? One more factor is needed. These are not one more factor. Basically 10 more factors are needed. This is of degree 20, no? This is of degree 20. So 10 more factors are needed into Qx. See, I have taken over here. Px minus x square. Px minus x square is 0 for these many values. Px minus x square is x into x minus 1, x minus 2 and so on till x minus 9 into Qx, because Px is of degree 20. So Px minus x square is also of degree 20. Are you getting my point, what I'm trying to say? Yes or no? Clear hai? ठीक है? So what is the degree of Qx now? The degree of Qx is basically what? What is the degree of Qx? Degree of Qx is 10. Degree of Qx is 10. Degree of Qx will be 10. Why? Because this is of degree 10. 10 many values are there. 10 many values are there. Okay? So 10 plus 10 will give you 20. Anyways. So this is basically your Qx. So now can we write down Px in a more general form? Px is how much? Px will be this much. Focus on this line. So what is Px next? Px will be x into x minus 1, x minus 2, x minus 3 and so on till x minus 9 into Qx plus x square. Simply bring this on the right hand side. Or simply bring this x square on the right hand side. So we are having P of x square. P of x will be x into x minus 1, x minus 2 and so on till x minus 9 into Qx plus x square. This is basically your Px. ठीक है? This is basically your px. Now what you have to do is you have to find out what is qx. What you have to do is you just have to find out what is qx. So next our target is to find out qx. So to find out qx, what we'll do, again we'll take the help of this condition. P of x is p of minus x. Again we'll take the help of this condition. P of x is p of minus x. ठीक है, यही पे ही we have found out px ना, so we'll find out what is p of minus x. What is p of minus x? Minus of x into minus x minus 1 and so on so forth till minus of x minus 9. Q of minus x. And this will still remain to be plus x square because minus of x square is the same as x square. And simply equate these two. P of x is p of minus x. I hope this much is clear to all what I'm trying to do over here. Q of x, I need to find out what is q of x. Again, I'm using this condition. P of x is p of minus x. Getting my point? So x into x minus 1. Again, same thing. Say that simply equate these two. X into x minus 1, x minus 9 and so on. Simply equate these two. I'm equating these two. Let me erase all these things so that workings are clearly visible to you. So I'm equating these two, see. So what we are getting from here, x into x minus 1, x minus 2 and so on till x minus 9 multiplied by qx. X square and x square will cancel from both the sides. Yes or no? Are x square and x square will cancel na? So what is remaining? Into qx, and similarly x into x plus 1, x plus 2 and so on till x plus 9 into q of minus x using this condition. Target is what? To find out qx. Okay. Now see over here. You have done these kind of questions. This is next what we are doing. This is something which you need to see very carefully. Next, what are we doing is put x is equal to minus 1, minus 2 and so on till minus 9. Why? Why minus 1, minus 2 and so on till minus 9? Why do we do this thing? Because you need to check very carefully over here कि by putting x to be minus 1, put the value of x as minus 1. Right hand side will become 0. Right hand side will become 0, yes or no? Right hand side will become 0. Similarly, put the value of x to be minus 2. Right hand side will become 0. Left hand side won't be 0. Right hand side will be 0. हाँ या ना? है ना? Right hand side will be 0. So all these values, see q of minus 1, q of minus 2 on all these values will become 0. Q of minus 1, q of minus 2, q of minus 3, all these values will become 0. Yes or no? Are you getting my point what I'm trying to say? Right hand side will become 0. Don't you think q of minus 1 will become 0? Similarly, q of minus 2 for minus 2. Q of minus 2 will become 0. Similarly, q of minus 3 will become 0 and so on till q of minus 9 will become 0. Got it? Which means q of minus 1, look at this thing, q of minus 1 is 0. Q of minus 1 is 0. Q of minus 2 is 0. What is the meaning of this thing? These are the roots. Q of minus 9 is 0. What is the meaning of this thing? These are minus 1, minus 2 and so on till minus 9 are basically what? The roots of qx. These are the roots of qx, yes or no? These are basically your roots of qx. So if the roots are known to us, so now can we write this thing qx as? What is qx? Now can we write down qx? What will be qx? Qx will be x plus 1, x plus 2. These are the roots now. Are minus 1 is one of the root. So x plus 1 is the factor. So x plus 2, x plus 3 and so on till x plus 9. Okay? But these are 9 values. You have proved earlier that qx is a polynomial of degree 10. Qx is a polynomial of degree 10. These are of 9 values. Hai na? These are basically of 9 values. So x plus s. So x plus p, let's say. One more factor. These are 9 values. Degree of qx is 10. So this will be what? This will be of 10 degrees. So I am taking one more factor x plus p over here. See? I am taking one more factor x plus p over here. Since qx is of degree 10. So next what we do is we simply take this qx and simply plug in the value over here in 1. Here. We have found out what is qx. I mean, we haven't found out what is qx actually. We have just estimated what is qx. Next, our target is to find out this p, value of p. Target is to find out the value of p. So, next target is to find out the value of p. So next what we do, we simply take this and simply plug in this value over here. Okay. Simply put it in 1. Here. Okay, here. Simply take this value of qx and simply put this over here. So x into x minus 1, x minus 2 and so on till x minus 9 into qx. Okay. Now plug in the value of qx. What is qx now? X plus 1, x plus 2, x plus 3, and so on till x plus 9 times of x plus p. So x into x minus 1 and so on till x minus 9, and then multiplied by qx. This portion is x plus 1, x plus 2, and so on till x plus p is just the qx part. Okay? And same thing goes on the right hand side. X into x plus 1, x plus 2, x plus 3, and so on till x plus 9. Then multiplied by q of minus x. You have qx. So what is q of minus x? X minus 1, x minus 2, and so on till x minus p. Minus, minus, minus. All in minus. ठीक है? This will be q of minus x. तो बस हो गया ना? तो from here you will find out what is p. You will find out what is p from here. Okay. Now, once you compare the coefficients, you will find out what is p from here. See, all coefficients are matching over here. You can see all these values are matching over here. Can you see over here? Here we are having x into x minus 1. Okay. X भी है. Here we are having x. Here we are having x. Okay. Similarly, देखो x plus 1 is present over here. X plus 1 is present over here. X plus 9 is present. X plus 9 is present somewhere over here. We are having x plus 9 as well. ठीक है तो x minus 1, similarly here also we are having x minus 1. All terms are getting matched over here. So once you compare the coefficients, similarly you will obtain p of all terms are matching, right? And the polynomial is true for all values of r. So once you match the coefficients, similarly you will get p of p will be 0. Here we are having x plus p, here we are having x minus p. X plus p and x minus p. समझ पा रहे हो ना? X plus p and x minus p we are having. So this will cancel out. So 2p will be 0 and p will be 0 from here. Match the coefficients. So p will be 0 from here. You will obtain p0. P0 means this part is 0. This part is 0. So you will find out what is qx. What is qx? Qx will be x plus 1, x plus 2, x plus 3 and so on till x plus 9 multiplied by x. Clear, eh? So you obtain what is px next. You have found what is qx. If p is 0, then what is qx next? Qx will be x plus 1, x plus 2 and so on till x plus 9 multiplied by x. Okay. So what is px? How do we find out px next? Px is given. What is px? Px is x into px. What is px? X into x minus 1, x minus 2, x into x minus 1, x minus 2 and so on till x minus 9 into qx. Now qx is known to us. What is qx? X into x plus 1, x plus 2 and so on till x plus 9. ठीक है? फिर plus x square. This is basically your qx. This is basically your qx. I mean px. This is px. And you want to simplify this further, you can write this as x square into x minus 1. Write this in a more decent format. See, x into x will give you x square. X into x will give you x square. So x square into x minus 1, x minus 2 and so on till x minus 9 multiplied by x plus 1 times of x plus 2 and so on till x plus 9 plus x square. And in a more decent format, you can write this as x square into x square minus 1. X minus 1 into x plus 1. X square minus 1. X minus 2 times of x plus 2 is x square minus 4. है ना? And so on continues till x square minus 9 square plus x square. This is your polynomial. Now go through this thing and tell me how many of you are having doubts. See, once you have found out this polynomial px, now what is px? Px is x square into x square minus 1 into x square minus 4 and so on till x square minus 9 square. Take and plus x square. Take it. They are asking you to find out what is limit extending to 0 px upon sine square x. They're asking you to find out what is limit extending to 0 px upon sine square x. So limit extending to 0 px upon sine square x, which means x square into x square minus 1, x square minus 2 square and so on till x square minus 9 square plus x square, or if divided by sine square x. This is what they are asking for. So from here, the very first thing what we'll do is we can clearly see sine square x and x square is present. So one thing we can do is we can take out this x square over here, common, and divide it with sine square x. The first thing is you divide by sine square x over here, x square, sorry. You divide by x square over here. So this quantity will become plus 1 divided by sine square x, divided by sine square x divided by x square. Why do we do this thing? Because we can clearly see one sine square x and x square is present. So what happens is as x tends to 0, once you distribute the limit, this quantity will tend to 1. है Same thing as sin x upon x whole square. Sin x upon x whole square, so this quantity will tend to 1. So limit extending to 0, x square minus 1, you're left out with this quantity, x square minus 1, x square minus 2 square, and so on till x square minus 9 square plus 1. Okay. So next you simply plug in the limits, the form is gone. So next you simply plug in the limits. So as x tends to 0, this will become 0. So we are left out with minus 1 into minus 2 square, minus 2 square, फिर minus of 3 square, and so on till minus of 9 square. Minus of 9 square, then plus 1. So that's basically 1 minus 9 factorial whole square. What is this? 9 factorial whole square, no? Minus sign will remain because there are 9 terms. Minus 9 terms, minus and all minus signs will remain because there are 9 terms over here. So 1 minus 9 factorial ka whole square. This is your final answer. 1 minus 9 factorial ka whole square. Like I said, the limit was very easy. Once you figure out the px, limit is very easy. Okay, so next we move on to ISI 2020 PYQs. Look at the question. What does the question say? Let a real valued sequence xn be such that limit n tends to infinity n times of xn is 0. So this is a question which is based on limit of a sequence. Normally these kind of questions are taught under real analysis because these are, limit of a sequence, not a function is given. It's not a function. Okay? But whether it's a limit of a sequence or a function, in some of the questions of sequence, limits of a sequence, we can solve some of the questions using, the concepts of limits of a function also. Okay? Likewise, what we learned actually. Okay, na? Sandwich theorem, all sort of things. So we can solve some of the questions of limit of a sequence using concepts of limit of a function also. Okay? So limit n tends to infinity, n times of xn is given to be 0. And we need to find all possible real values of t such that limit n tends to infinity, xn multiplied by log n whole to the power of t is equal to 0. Okay, so using this thing, we need to find the values of t for which this limit is also equal to 0. They have given the limit. The limit is given to be, this limit is given, limit n tends to infinity, xn into log of t. This limit is given to be 0, log of n, this limit is given to be 0. Okay, we need to utilize this. So the best thing is basically, we need to find the values of t for which this limit is given to be 0. Acha, so limit is distributive. So one thing we can notice from here is, if this thing is given n into x to the power of n, n times of xn is given. So what we can do is we can multiply by n over here and divide by n over here. Why? Because this quantity limit is what? Distributive. So once you can distribute the limits over here, this quantity is absolutely 0. And this quantity will be a separate limit, let's say L or something. Okay. We need to find the values of L for which t will be 0. We need to find the values of t for which L will be 0. Got it? We need to find the values of t for which L will be 0. This limit is given to be 0. Once you distribute this thing, once you distribute the limits over here, this limit is absolutely given to be 0. So we just only need to focus on this limit to find those values of t for which this limit is equal to 0. That's it. Okay. Now there can be many cases. T can be positive, negative, or t can be 0 also. Okay. T can be positive, negative, or t can be 0. So देखो first case, if t is 0. If t is 0, what happens if t is 0? So limit n tends to infinity, L will be what? I am focusing on L. Okay. So L will be, to limit n tends to infinity. It's a very simple limit. If t is 0, so something raised to the power of 0 is 1 only. So 1 by n, which will tend to 0 only. So in this case, L will be 0 only. Okay. Now t can be negative. T can be negative or t can be positive. I'm showing you the case of negative first. If t is negative, what happens? If t is negative, so limit n tends to infinity. Okay. Acha, you do in this way. You write this in this way. You write this in a more decent way. See, if t is negative, take t is equal to, stylish way of writing. If t is negative, take t is basically minus p. where p is positive. Take t is minus p. What happens? Therefore, limit n tends to infinity, log of n raised to the power of minus p divided by n. This becomes limit n tends to infinity 1 upon n times of log of n raised to the power of p. And as n tends to infinity, all of these will tend to infinity because p is positive. Okay? In this case also we are getting 0. The limit is 0. As n tends to infinity, 1 by this infinity will tend to 0 only because p is positive. So third case is there. Third case kya hoga? Third case is if t is positive. Now here comes the main twist. If t is positive, what happens? Kya question hai? Question. What is the question? First two cases can be combined also. You can say t is less than or equal to 0 as well. I'm showing you explicitly over here, but first two cases can be combined. Same thing. Acha. Now t is more than 0. What happens for t more than 0? So if t is more than 0, so we have L to be limit n tends to infinity. Limit is given by log of n whole to the power of t divided by n. We have this limit. Now t is more than 0, then what we'll do over here? Dekho. So first time I'm using the L'Hopital's rule over here for the first time. I'm using the L'Hopital's rule over here. See, without L'Hopital's rule, this will be difficult because the thing is you don't know the expansion of log n. Without expansion, I mean using expansion also, even if you know this thing, you cannot solve this using expansion. This will be difficult. Neither you can think of using sandwich theorem over here. The best thing is to go by the L'Hopital's rule over here. So see, so if I use, first you see the format. Format is what? What is the format over here? Basically, we are having as n tends to infinity. If t is positive and as n tends to infinity, so this will tend to infinity as well. So basically, we are having infinity by infinity. So we can think of using L'Hopital's rule. So once you use L'Hopital's rule here, so you will start differentiating this thing. So first time t will come down, log of n will be there, multiplied by t minus 1, whole raised to the power of t minus 1. Okay, multiplied by what? Differentiation of log n, which is 1 by n. Or niche we are having by n divided by n, which is 1 only. Differentiation of n, we are differentiating with respect to n, right? So that will be 1 only. Acha, next. Again, you are differentiating. So you are getting the same thing. You are getting a similar kind of thing. Now the only change is you are getting one more extra t and t minus 1. Or फिर से divided by n. Again, you are getting divided by n. So once you differentiating this thing, once you differentiate this thing once again you differentiate this thing. So this will become t times of log of n whole to the power of t minus 1. So t minus 1 will come down next. Log of n raised to the power of t minus 1 minus 1, which is t minus 2. Take him. Then multiplied by into differentiation of log of n, which is 1 by n. और नीचे यहाँ पे divided by n was there, divided by n, which is once again 1. So this thing will continue. This 1 by n will never go off, first of all. Okay? So if you keep on differentiating this thing n number of times, okay, or rather k times. We have used n over here, so let's use k times. Okay? The first time you're differentiating this thing, t comes down. First time you're differentiating this thing, t will come down. Second time you're doing it, t minus 1 comes down, right? T comes down, t minus 1 comes down. Third time you'll be doing this thing, t minus 2 will come down. So for kth number of times, bolo, what is the kth term? If you differentiate this thing k number of times, 1 by n will continue. What is the kth term over here? Let's say kth term. What is the kth term? T into t minus 1, t minus 2 and so on till how much? T minus, bolo, kitna hoga? What is the kth term over here? First time you are differentiating this thing t minus 0. Second time we are having t minus 1. Third time we are getting 2 over here. Third time we are getting 2. Fourth time में 3. So kth time में k minus 1. Yes or no? K minus 1. For kth time, we'll be having the kth term. The kth term differentiation will be k minus 1, t minus k minus 1. Or more specifically, t minus k plus 1. Remove the brackets, t minus k plus 1. Okay, and 1 by n will still continue. In any case, 1 by n will still continue. I have generalized this thing. I have simply generalized this thing. 1 by n will still continue over here. Are you getting my point? Log of n will be there. Log of n. What are we doing is we are differentiating this thing k amount of times. Take it. Kth number of times. So k number of times means t minus k will be there. For differentiate, first time you are differentiating this thing, the power is t minus 1. Second time my power is t minus 2. Third time my power is t minus 3. So kth number of times mein t minus k is the power, and 1 by n will continue. 1 by n will simply continue. Are you getting my point? What I'm trying to say? Yes or no? This is the differentiation of this term k number of times. 1 by n will still continue over here. Okay. Now you choose one value of k. Let's say you choose k such that देखो you choose k such that k is greater than t. Choose k such that k is greater than t. What is the meaning of this thing? K is greater than t, which means k minus t is, या फिर t minus k बोलो, t minus k is less than 0. ठीक है. Why we are doing this thing? You will get to know right now itself. देखो k is more than t. I'm choosing k such that, choose k in such a way कि k is more than t. This part, don't you think this part is just a constant? Don't you think this part is just a constant? This part is just a constant. Sorry, this part. Don't you think this part is just a constant? It is just a constant which we have considered. So technically this can be taken out. This thing can be taken out, this limit. So we are left out with, actually we are left out with limit n tends to infinity k times of, देखो k times of, ठीक है, k times of the remaining part. Remaining part is what? 1 by, can I say this thing? 1 by log of n. ठीक है, 1 by log of n whole to the power of t minus k. T minus k is negative. ठीक है, t minus k is, ये ठीक किया ना भाई? हाँ, t minus k is negative. So k minus t is positive. K minus t will be positive. नीचे जाएगा तो k minus t. Once you bring this down, this will become k minus t, and one more n is remaining. So n times of log n whole to the power of k minus t. And don't you think as n tends to infinity, this will tend to 0 only, because k minus t is positive. T minus k is negative, na? T minus k is negative. So k minus t is what? Positive. K minus t is what? Positive. ठीक है, k minus t is positive. So this quantity will what? Tend to 0 only. This quantity will tend to 0 only. So this limit will be also equal to 0. This limit will be also equal to 0. So limit n tends to infinity. In this case also, if t is positive also, this L will become 0 only. So this limit is equal to 0 for all values of t. So therefore answer is t belongs to all real numbers. This limit is equal to 0 for all real values of t over here. Now your question can be, sir, why did you choose k such that k is greater than t, and why not less than t? Okay, why not less than t? Why did you choose this thing? Choose k such that k is more than t, such that k is more than t. Why did you choose this thing? Why not less than t? देखो भाई, if you choose k less than t, what will happen over here is, देखो, for k less than t, k minus t will be what? K minus t is negative. K minus t is negative. ठीक है, तो this quantity will become negative. नीचे वाला quantity will become negative. So actually you are proving nothing. Actually you are proving nothing. If k minus t is negative, na, you will be proving nothing over here. This will still tend to infinity. Again this differentiation will continue. ठीक है. So the best way is to choose k to be positive only. This differentiation will keep on going on otherwise infinitely many times over here. है? So the thing is, the next, basically we are generalizing this thing. We are stopping at some particular point where t minus, where this is taking the value of, we are differentiating this for the kth. We are generalizing this thing for k amount of times. We are generalizing the differentiation for k amount of times. So log n raised to the power of t minus k. That is why I'm choosing k such that k is positive, k is more than t, such that k minus t is more than 0. And if k minus t is more than 0, this quantity will come down and this will become k minus t. And since k minus t is positive, so this quantity will tend to 0. Is this question clear? what I've done over here. Okay, we move on to 2019 PYQs. The very first question says, for all natural numbers n, an is given to be this thing for n many radicals. The first part of the question says, show that for n greater than or equal to 2, an is this quantity. And then you have to find out this particular limit actually. So again, this is something you just need to very carefully observe over here. Otherwise, the question is very simple. Okay. First part is only difficult. So dekho bhai. So we are having square root of 2 minus square root of 2 plus the remainings are all plus. We are having n many radicals over here. These are n minus 1 terms. N minus 1 radicals are there. N minus 1 radicals. These are n minus 1 radicals are there. Okay. So first I'm dealing with this bracket. First I'm dealing with these square roots over here. Okay. First I'm dealing with these square roots over here. Okay. So dekho bhai, first we are having square root of 2. So one thing, the only trick over here was to identify that this square root you need to, dekho, here they have said ki an, you need to prove for an is 2 sine pi upon 2 to the power of n plus 1 or something. So you need to relate something, all these terms with trig formulas. You need to relate all these terms with respect to the trig formulas. So root 2 is basically 2 cos pi by 4. Root 2 is 2 cos pi by 4. Your root 2 is actually 2 cos pi by 4. Cos pi by 4 is 1 by root 2. So root 2 is 2 times of cos pi by 4. Okay. And you consider this to be cos of theta, let's say. 2 cos theta. Why do we do this thing? Because here you will get the simplifications in terms of cos of theta. An will be simplified in terms of cos of theta. So for the first time, we'll simplify this. We'll simplify these n many radicals over here. Not n many, n minus 1 many. These are n minus 1 radicals. Except this bigger square root of 2 minus, except this remaining minus sign, we have n minus 1 radicals over here. So 2 minus, we'll simplify this first. We'll start simplifying this 2 plus 2 and so on till under root of 2 plus 2 cos theta. The first time we are having cos of theta. I'm writing this as cos of theta. Okay. And this gets further simplified to 2 minus under root of 2 plus and so on. You take out a 2 common over here. This gets simplified to, you can see over here, you take 2 common from here. So this gets simplified to 1 plus cos of theta. So this is 2 times of 2 cos square theta upon 2. So which is 4 cos square theta upon 2, and you take the square root, this becomes 2 cos of theta. 2 cos of 2 plus 2 cos of theta upon 2. Okay. For the second time, this becomes cos of theta. This becomes cos of theta upon 2. Okay. Starts from cos of theta, then this becomes cos of theta upon 2. Again, you do the same thing over here. So we will be getting 2 times of 1 plus cos of theta upon 2. So you take out a 2 common from here and you simplify this thing, which is 2 cos square theta upon 2 square. Okay, theta upon 2 divided by 2, which is 2 square. So that's 4 cos square theta upon 2 square. And finally, we will be having this as square root of 2 plus 2 and so on till 2. And this will become under root of 2 plus. This term will become 4 cos square. So 2 cos theta upon 2 square. Okay. Theta upon 2 square. And this will continue. This will continue. 2 square. The next term will be what? The next term will be 2 minus under root of 2 plus and so on till root over of 2 plus 2 cos theta upon 2 cube, and this will continue. So for the first time you will see, for the first time we are getting, when we are taking this as cos theta, we are getting this as cos of theta only, cos of theta, which is the same as cos of theta upon 2 raised to the power of 0. Then second time we are getting theta upon 2, which is second time. For the second time we are getting, second step we are getting theta upon 2 square. Sorry, 2 raised to the power of 1. For the third step we are getting, third time we are getting 2 squared, theta upon 2 square over here. Okay. For the first time 0. For 1 we are having 0. For the second time we are getting 1. For the third time we are getting 2. Right? For the fourth time we are getting 3 over here. So in general, if we extend this thing to for n many radicals over here, n minus 1 radicals, because we have n minus 1, we are simplifying this much portion. If we are having n minus 1 radicals over here, so what can you say? What will be the n minus 1th term? What is the n minus 1th step over here? So for n minus 1th step, this will be 2 minus this quantity will reduce itself to how much? 2 cos square. How much? For 4, we are having 3, 1 less than this thing. So for n minus 1, this will be n minus 2. So theta upon 2 cos square, or not cos square, cos. 2 cos theta upon 2 to the power of n minus 2. Getting my point? This will be square root of 2 minus 2 cos of theta upon n minus 2. Right? Yes or no? And finally, we will be simplifying this thing too. Finally, we can simplify this next. Again, we simplify this thing. So this will become 2 minus. Now 2 minus. Again, you take out a 2 common. So 2 times of 1 minus of cos theta. 1 minus cos theta means 2 sine square theta. So 2 sine square. 2 sine square theta upon 2 raised to the power of n minus 2. So theta upon 2 raised to the power of n minus 2 divided by 2. So divided by 2 means 2 raised to the power of n minus 1. This will become 2 raised to the power of n minus 1 finally. So theta upon 2 raised to the power of n minus 1. है ना? 2 sine square theta. 2 sine square theta upon 2 raised to the power of n minus 1 divided by 1. So 2 raised to the power of n minus 1. And finally, we are getting this to be 2 sine of theta upon 2 raised to the power of n minus 1. 2 sine of theta upon 2 raised to the power of n minus 1. This is your final thing. This is your an. This is your an. Okay. Now next what we do is we simply replace the value of theta. We simply replace the value of theta. What was theta? Initially what we have taken theta. Theta is basically pi by 4. So this will become 2 sine pi upon theta upon. What is theta? Theta is pi by 4. So pi by 4. 4 means 2 square. So 2 square multiplied by 2 raised to the power of n minus 1. Okay. So 2 times of sine of pi upon 2 raised to the power of 2. So 2 plus n minus 1. Okay. So 2 minus 1, which is plus. So 2 raised to the power of n plus 1. This is basically your theta. An. This is basically your an. That's what they have asked to prove. 2 sine pi upon n plus 1. Now the second part of the question is simply asking you to calculate this limit. So limit n tends to infinity. This is easy. Second part of the question is quite easy. Limit n tends to infinity. 2 to the power of n multiplied by an. So an means basically 2 to the power 2 times of sine of pi upon 2 to the power of n plus 1. The second part of the question is simply asking you to calculate this limit. Okay. Not that difficult. We are getting this is 2 to the power of n plus 1. 2 raised to the power of n plus 1 and minus. So we can simplify this thing. This is 2 raised to the power of n plus 1. This will become 2 raised to the power of n plus 1. Where to do? We can do it here. So we have proved an. So next is what? Next is to just figure out this limit. So limit n tends to infinity. Limit n tends to infinity. 2 to the power of n times of an. So 2 raised to the power of n multiplied by 2 times of sine of pi upon 2 to the power of n plus 1. So this will become limit n tends to infinity. 2 to the power of n plus 1. 2 to the power of n plus 1 into sine of pi upon 2 to the power of n plus 1. So now you can clearly see that it's better to bring this down. It's better to bring this down as 1 upon 2 raised to the power of n plus 1. Bring this 2 raised to the power of n plus 1 down. You can clearly see that this will come to some format. As n tends to infinity, this will tend to 0. So sine of same by same format. Sine of same by same. Now same by same means one thing is missing over here. Pi is missing. Pi is missing. So we multiply and divide by pi over here. We multiply and divide by pi such that this quantity will become 1. This quantity will become 1. So we are left out with 1 by pi. 1 upon 1 by pi, which is pi only. Answer is pi. Next, we move on to 2018 PYQs. So here we have the first question, which says that fx is half times of x sin x minus 1 minus cos x. We have to find the smallest positive integer k such that this limit is not equal to 0. Best way to solve this question is using the expansion. So half times of, look at this thing. Limit, ISI loves expansion. So limit extending to 0 fx upon x to the power of k. You can use L'Hopital's rule and try to solve this as well. one of my students did this using L'Hopital's rule. So limit extending to 0, half times of x sin x minus 1 minus cos x upon x to the power of k. So limit extending to 0, half into x sin x. So half into x sin x means, let's say I'm taking the expansion of sin x. Okay, now what is the expansion of sin x? Again, I'm saying Maclaurin series expansions are extremely important. You need to memorize all of them. Expansion of sin x. You need to memorize all the expansions of Taylor series expansions. X minus x cubed by 3 factorial plus x to the power of 5 by 5 factorial and so on. So once you memorize this expansion of sin x, cos x will come free of cost. What is cos x? Differentiation of sin x. Differentiate this thing. What will happen? So 1 minus x square upon 2 factorial plus x to the power of 4 upon 5 factorial and so on. Right? So this becomes x into sin x. Sin x means x minus x cubed by 3 factorial plus x to the power of 5 upon 5 factorial and so on. This will continue minus of 1 minus cos x. So 1 minus cos x means 1 minus x square upon 2 factorial plus x to the power of 4 upon 4 factorial and continues. And divided by x to the power of k. So limit extending to 0, half times of. Okay, now we see some cancellations here. This term and this term is getting cancelled. So we are left out with x. You multiply this x as well, x square. So we are having x square minus of x to the power of 4 by 3 factorial plus x to the power of 5 by 5 factorial, right? And so on. And then minus of, okay, now this becomes minus minus plus. Be very careful. This becomes minus minus plus. Here we add one more minus. So this is minus minus plus x square upon 2 factorial. Okay, minus minus plus, then minus plus minus x to the power of 4 upon 4 factorial and so on. This continues upon x to the power of k. Okay, now so we can see some cancellations, more cancellations. See, x square and this x square upon 2 factorial cancels out. Right, x square and this x square upon 2 factorial, which is the same as x square upon 2, will cancel out, and these terms are remaining over here. Some of these terms are remaining. X to the power of 4 upon 3 factorial and x to the power of 4 upon 4 factorial, right? What is remaining? 1 upon 2 times of 3 factorial into x to the power of 4. Okay, these terms are remaining, plus 1 upon 2 factorial, 2 times of 5 factorial into x to the power of 5. These terms are remaining over here. And here what else is remaining? Minus of this is cancelled, so minus minus plus. Okay, take out a minus common from here. So minus plus x to the power of 4 upon 4 factorial. Multiply with a minus sign. So minus, then next term will be minus x to the power of 6 upon 6 factorial. These are remaining. Upon x to the power of k as limit extending to 0. So what happens over here is, as x tends to 0, you can clearly see from here, x is tending to 0. So minimum k has to be 4 in order for this to be a non-zero quantity. Otherwise, if k is not 4, let's say, what happens is, if k is not 4, if k is 5 or something, okay, k definitely cannot be 3. Focus on the options. K cannot be 3. If k is 3, then what happens is this will become x cube. This will become x cube, and x to the, once you divide this thing, one of the x will remain over here, and as x tends to 0, all these will become 0. All these will become 0. Getting my point? Once you divide this thing, one of the x will remain over here. All these terms will contain x, and all these will become 0. And the answer you will end up getting the answer to be 0. Now I take the value of k to be 4. So we'll be getting x to the power of 4 over here. X to the power of 4, once you divide this thing, this quantity will cancel out. This will become x. The remaining terms will become 0, but this term will become non-zero. This term will remain, and your answer will be 1 upon 2 times of 3 factorial. Okay. Similarly, same thing goes for 5. Let's say I'm taking one more value. 5 and 6 will have the similar behavior. I'm taking x to the power of 5. Once you divide this thing, this term will cancel out, but unfortunately, you will not get cancellations over here. I mean, you will be getting 1 by x over here, which is remaining. And x tends to 0, this will become 1 by x. 1 by x will remain. Remaining terms will get cancelled, fine. Remaining terms will get 0 or some terms over here, but divided by x will be there. Again, that will be a problem kind of thing, divided by x is remaining and x will tend to 0. Okay, so k has to be 4 over here, so option B must be correct. Okay, we move to the next question. Next question says, some conditions are given. These are some A, B, C are real numbers. Some conditions are given such that for all n belongs to n, there exist triangles of side lengths a raised to the power of n, b raised to the power of n, and c raised to the power of n. We have to prove that the triangles are isosceles. Okay, we have to prove that the triangles are isosceles over here. So now this is technically not a question of limits, but somehow a very basic condition of limits is being involved over here. Okay, technically this is not a question of limits. This is a geometry question. They're asking you to prove the triangles are isosceles triangle, and somewhere they have given this inequality over here. Equalities are present over here, which means that we have to prove that A is equal to B. Somewhere they have given this inequalities, I mean equalities over here, which definitely means that the equality will hold. And when A is equal to B, in that case, you might be getting some triangle will be isosceles triangle. Isosceles means you have to prove that the two sides are equal. Take it. So the best thing is you simply take some assumption and then simply proceed. Okay. So best way is what? Consider, let's say, this condition is given, right? A is greater than or equal to B, greater than or equal to C is greater than C, greater than 0. So this condition has to be maintained. Okay. So what I'm doing is, like I said, to prove the triangles are isosceles, some sort of equality is given. So somewhere we can think of this equality will hold. If A is equal to B, then the triangles will become isosceles. And also the triangles are of side lengths A raised to the power of n and B raised to the power of n. Fine, no problem. So the first assumption what we are taking is basically you consider that they, let's say, simply consider A is greater than B. Simply consider A is greater than B. The first assumption which we are taking is basically A is greater than B over here. So if A is greater than B, what we are getting from here? If A is greater than B, acha, one thing though, if A is more than B, definitely A is more than C also. If A is more than B, then this implies A is more than C automatically. Even we don't need to consider the value over here. If A is more than B, automatically this will imply A is more than C. Okay. Automatically this will imply A is more than C because of this condition given. Okay. Okay. So what we can say from here? Now the thing is, we have to prove that there exist triangles of side length this. The side lengths of the triangles are A raised to the power of n, B raised to the power of n, and C raised to the power of n. Okay. So what we can do is, if these are the side lengths of the triangle, so by triangle inequality, we can say, by triangle inequality, what else we'll do? By triangle inequality, we can say, we have taken this to be the largest side, no? We have taken this to be the largest side. So by triangle inequality, we can say A raised to the power of n is less than B raised to the power of n plus C raised to the power of n. And equality will hold over here. A raised to the power of n is less than or equal to B raised to the power of n plus C raised to the power of n. I hope you people know what is triangle inequality, some of the two sides is greater than the third side. Some of the two sides of a triangle is greater than the third side. So A raised to the power of n is less than or equal to B raised to the power of n plus C raised to the power of n. We are simply using triangle inequality over here. Okay. Mind it, all these sides are, these are basically sides of the triangle. These are real numbers. These are real numbers, and also these are positive. Real numbers as well as positive. Okay. And we are considering that A is more than B, which also means that A is more than C as well. So now by triangle inequality, we are getting this thing because these are the side lengths of the triangle. So we are simply using triangle inequality over here. Now the thing is, you can see one thing very clearly. Let's see, here we are getting, here what we have considered, A is more than B, right? A is more than B. And also these are positive numbers. Also these are positive numbers, right? A is more than B and these are positive numbers. So don't you think that if A is more than B, then B by A will be what? Less than 1. A is more than B, which means B by A is what? Less than 1. And also B by A is positive because these are positive numbers. A is more than B, and A and B are all positive numbers. So definitely B by A is what? More than 1, less than 1, and definitely more than 0. And similarly, C by A as well. C by A is also less than 1 and greater than 0. Okay. So from these two only, you can decide what to do next. Is divide by a raised to the power of n. Divide by a raised to the power of n over here. What we do is we simply divide by a raised to the power of n on both the sides. What is the benefit over here? If you take limit n tends to infinity over here, if you take limit n tends to infinity, b by a raised to the power of n, this will tend to 0. You know this thing? Any proper fraction raised to the power of infinity will tend to 0. And which is the same thing goes with this as well. Limit n tends to infinity c by a. This will also tend to 0. Both of these are tending to 0 basically. What is the meaning of this thing? For larger values of n, this is tending to 0 and this is also tending to 0. For larger values of n, this is tending to 0 and this is also tending to 0. Are you getting my point, what I'm trying to say? For larger values of n, this is tending to 0. Very large value of n, which means for very large value of n, this inequality will become something like this. For very large n, this inequality will become something like this. 1 is less than or equal to 0, which is absolutely not possible. So it simply means that for larger values of n, this will fail. And they have said that this is true for all positive numbers, positive real numbers. So definitely this will not hold. N belongs to all natural numbers. This will definitely not hold for all natural numbers. For larger values of n, this is failing. Okay. So basically A cannot be more than B. Also A cannot be less than B. A cannot be more than B. A cannot be more than C. A cannot be less than B as well. A cannot be less than C as well. So the only possibility is basically A is equal to B. Only possibility is A is equal to B. And if A is equal to B, we have A raised to the power of n is equal to B raised to the power of n for all n belongs to n. Because n is natural numbers over here. You can raise the power. So if A is equal to B, so A raised to the power of n will be also equal to B raised to the power of n. So hence proof. So the triangle is what? Isosceles triangle. Therefore, the triangle is isosceles. Take it. Okay. Okay. Next one. Next question from ISI 2016 previous year questions. Next question says, consider two distinct arithmetic progressions AP, each of which has a positive first term and a positive common difference. So you consider two arithmetic progressions which is having positive first term and positive common difference. Okay. Sn and Tn with the sums of the first n terms of these AP. Then the question is, we have to find limit n tends to infinity Sn divided by Tn. A very simple question. You consider two APs and you find out their Sn and Tn, which is the sum of the first n terms, right? You find sum of the first n terms. So let's say I consider the first AP. First AP is having a common difference. First term is A, common difference is small d, let's say. And then the second AP is having a first term is capital A and common difference is capital D, let's say. Okay, so and they are asking you to find out what is limit n tends to infinity Sn divided by Tn. What is Sn? The sum of the first n terms. Formula is known to you. N by 2 multiplied by 2a plus n minus 1 times of d divided by, similarly, n by 2. Number of terms is the same for all of them, right? Because all of them are having n terms. And this will be 2a plus. Only common difference and first term is only different over here. So they are asking you to calculate what is the value of this thing. So n by 2 and n by 2 cancels out. So we are having limit n tends to infinity. We are having 2a plus nd. So if you simplify this thing, we are having 2a minus of d, 2a minus d plus nd. And similarly here also we are having 2a minus d plus nd. Okay. So you can clearly see over here, you can directly see the answer if you know the shortcut. You know, polynomial by polynomial we are having. The form is what? Infinity by infinity. What are we having? Polynomial by polynomial. Degree is the same. So answer is for the highest degree, coefficient of the highest degree divided by the coefficient of highest degree. Yes or no? Coefficient of the highest degree as n tends to infinity. What is the variable? N. Coefficient of highest degree divided by coefficient of highest degree. Answer is d by d. Remaining part will be 0. And if the shortcut is not known to you, what you can do is you can simply use the logic to solve this thing, that limit n tends to infinity. Then you have to write down one more step, limit n tends to infinity. divide by n. Whichever quantity is tending to infinity, simply divide by n. So 2a minus d divided by n plus d divided by 2a minus d divided by n plus d. So as n tends to infinity, this will tend to 0 and this will also tend to 0. So your answer will be d upon d. So what is this? The common difference of the first, the ratio of the common difference of the first term divided by the common difference of the second AP. Okay, so now you see the options very carefully. It's neither 0 nor infinity. So first two options are discarded. So third one is saying the ratio of the first terms of the AP. No. Last one is saying the ratio of the common difference. Option D is correct. Ratio of the common difference of the AP. The next question is saying f such that R2R be a non-zero function such that limit extending to infinity fxy. Okay, some function is given fxy divided by x cube exists for all y greater than 0. And gy is given to be this. And g of 1 is also 1. Okay. Question is we have to find g of y. Okay, g of y. They're asking you to find out g of y. So g of y is given to be limit extending to 0. Limit extending to infinity fxy. This is what they have given. Fxy divided by x cube. Okay. And this limit is given to be existing. They are saying this limit exists. G of 1 is given to be 1. Okay. G of 1 is given to be 1. This g of y is basically a function which is inbuilt with limits. G of y is basically a function which is inbuilt with limits, right? Limit extending to infinity fxy divided by x cube. So one thing you can figure out from here, it's a function only, right? And limit is dependent on x. So y is a constant with respect to x. Okay, so once we can put the value of y to be 1. Y is the function value, right? And y is a constant with respect to x. So we can put the value of this to be 1 and this becomes g of 1 is limit extending to infinity f of x divided by x cube. And this quantity is given to be 1. So we have one more value from here, that limit extending to infinity fx upon x cube is given to be 1. Look at this manipulation. G of y is given to be this, no? G of y is given to be this. I am writing g of y once again. I am manipulating g of y. Look at this g of y. Limit extending to infinity f of xy divided by xy whole cube. Okay. And then multiplied by y cube. I am manipulating this again once again. I'm manipulating this once again. F of xy divided by xy. And forcefully I'm taking out y cube over here. I'm multiplying and divided by y cube. Multiply and divide by y cube over here. Okay. Multiply and divide by y cube. Now see over here. Why we have done this thing? Look at this format over here. Can you now see the format? Can you now look at this format over here? Look at this limit format. Can you now see over here that as x tends to infinity, xy will also tend to infinity. So even if you replace x by xy, this will not matter. F of xy divided by xy whole cube, this will not matter. This will still tend to infinity. Since xy, this limit will still become 1. Because as x tends to infinity, xy also tends to infinity. So this limit will still become 1. So that's basically 1 times of y cube. Limit is dependent on x. So 1 times of y cube, which is y cube only. So g of y will be y cube only. Option D is correct. Next, we move to this question. The question says for alpha belongs to 0 to 3 by 2, define xn to be n plus 1 raised to the power of alpha minus n raised to the power of alpha. We have to find the limit n tends to infinity xn. We have to find limit n tends to infinity xn over here. Okay. So what is xn given? Xn is given to be n plus 1 raised to the power of alpha minus n raised to the power of alpha. So basically this we have to comment on the value of alpha as well. Corresponding to what values of alpha, what is the value of limits actually? What is this value of limit going on? Let's say if alpha is 1, you can clearly see if I take alpha is 1, then this will xn will become n plus 1 minus of n. So in that case, xn is 1 only, and limit extending to infinity xn will be also 1. Limit n tends to infinity xn, that will be also 1 only because it's a constant function. So that's 1 only still. Okay. Now we have to check this thing that whether this is 1 for all values of alpha or not. We have just taken one of the values of alpha, for which alpha belongs to 0 to 3 by 2. We have to consider this interval as well. Alpha is equal to 1. We have just checked for one of the values. Okay, what about the remaining places like 0 to 1 or 1 to 3 by 2? What about the remaining places? Yeah, what about the remaining places? We have just taken one of the value because this was looking like a simpler value. Clearly from basic visualization, we have taken one of the value to be alpha is 1. What about the remaining values? 0 to 1, open 0 to 1 and open 1 to 3 by 2. Okay, so when alpha is not equal to 1, this is what we need to verify, the next case. So in that case, xn is, what I am doing is, let's take out n raised to the power of alpha common. Let's take out n raised to the power of alpha common such that this becomes 1 plus 1 by n. 1 plus 1 by n raised to the power of alpha. Okay, these kind of simplifications are known to you, minus of 1, right? I'm taking out n raised to the power of alpha common, so we are having 1 plus 1 by n raised to the power of alpha minus 1. Okay, all right. So next what we are doing is, next look at this thing. Next what I'm doing, next I'm using expansion over here. I'm using expansion of 1 plus x whole to the power of n, binomial. I'm using expansion 1 plus x whole to the power of alpha. Okay, what is it basically? This will become 1 plus alpha upon n, 1 plus alpha upon n plus alpha into alpha minus 1 divided by 2 factorial into 1 by n square, and so on. This continues. This will continue, and minus of 1. You also have one more minus 1 over here. So this 1 and 1 will cancel out. What is the reason for doing this thing? Because once you take this n tends to infinity, once you make this as n tends to infinity over here, first of all, you simplify this thing. This is basically alpha upon, multiply this thing. This becomes alpha multiplied by n raised to the power of n times of alpha is alpha minus 1, n to the power of alpha minus 1 plus alpha into alpha minus 1 upon 2 factorial. This becomes n times of alpha, n raised to the power of alpha minus 2, and so on. This is what we are having in general. This is what we are having in general. Okay. All right. So what is the benefit? What is the benefit we are getting from here? This is xn. If I take limit x tending to infinity, because that's what they have asked to find. If I take limit x tending to infinity, or limit n tends to infinity xn, this will become limit n tends to infinity. Okay, alpha raised to the power of n raised to the power of alpha minus 1, alpha times of alpha minus 1, and so on and so forth. Basically, whatever terms are there. Okay. Now you can clearly see the values of alpha from here. If let's say alpha belongs to 0 to 1, okay, we'll check two cases. Alpha belongs to 0 to 1 and alpha belongs to 1 to 3 by 2. These two cases we haven't checked. If alpha belongs to 0 to 1, what happens? Here, if alpha belongs to 0 to 1, then don't you think that alpha minus 1, alpha minus 2, all these powers will become negative? Yes or no? If alpha belongs to 0 to 1, then alpha minus 1, alpha minus 2, all these powers will become negative, right? And negative means this will become divided by n. This n will come down, right? This n will come down. And as n tends to infinity, this will tend to 0. All of these will tend to 0. Yes or no? In this case, xn, this quantity, this will become 0. The limit will become 0. So in this case, limit n tends to infinity, xn will become 0. Got it? Got the logic? Yes or no? If alpha belongs to 0 to 1, this will become negative now. And this will come down. Alpha minus 1 is negative, which means 1 minus alpha is positive. So this will come down. This will become alpha divided by n. And as n tends to infinity, this will tend to 0. All these quantities will tend to 0. Now coming to this part. If alpha belongs to 1 to 3 by 2, limit n tends to infinity, xn will be how much? If alpha belongs to 1 to 3 by 2. 1 to 3 by 2, suppose I am taking, let's say 1.2 I am taking, 1.2. So 1.2 minus 1. 1.2 minus 1, this quantity is still positive. Similarly, 1.2 minus 2, this quantity is negative, fine. But unfortunately, this quantity remains to be positive. And if this is remaining to be positive, no matter what, if this is remain to be positive, which means as n tends to infinity, this will tend to 0. Sorry, this will tend to infinity. If this is positive, alpha minus 1 is positive. So as n tends to infinity, this will still remain to be infinity. Yes or no? So in this case, this limit will tend to infinity. So these are your possible values, 1, 0 and infinity. So option D must be correct, 1, 0 or infinity depending on the value of alpha. Okay, the next question says a function is given from 0 to 1 to minus 1 to 1. Be a non-zero function such that f of 2x is 3 times of fx. Okay, f of 2x is 3 times of fx and you have to find out limit extending to 0 plus fx. Now this is some relation is given. We can simplify this thing. The purpose for me to take this question was this was a very simple relation given. A very simple functional equation, which is what they're given actually. This can be easily simplified. And this is a very standard functional relation which you people face actually. So fx is, see, if f2x is 3 times of fx, then we can write fx as 1 by 3 times of f of 2x. Right? We can write this fx as 1 by 3 times of f of 2x. And similarly, we can repeat this process n number of times. We can repeat this process n number of times. This will never end. You can repeat this process. You can see over here, let's say what is f of 2x. Similarly, can we say from here? Can we say from here that if I replace x by 2x, if I replace x by 2x, so this becomes f of 2x, f of 4x, and this will become 3 times of f of 2x. Again, you find the value of f of 2x from here. F of 2x will be 1 by 3 times of f of 4x, which is 2 square x. So can I say from here, this is nothing but 1 by 3 into 1 by 3, which is 1 by 3 square f of 2 square x. Yes or no? Can I say this thing? And this process will be repeated. So the next term will be 1 by 3 cube. Okay, 1 by 3 cube and so on. This will continue. 1 by 3 cube f of 2 cube x. Fine. So this will continue for n number of terms. This process will be continued for n number of terms. So the question is, how much will take this thing? I mean, what is the definition of the function? How do we derive fx in that case? How do we find out fx? So fx is basically, this process will be, in reality, this process will be continued for infinitely many times. In reality, this process, no matter what, you can increase this to, you can increase this same thing to infinitely many times. You are doing this for the first time, then second time, third time, and so on. This will tend to n tends to infinity. You can make this, you can define this, you can define this fx. You can define this fx as limit n tends to infinity. As n tends to infinity, this process will continue. So you can define this function as limit n tends to infinity 1 by 3 to the power of n into f of 2 to the power of nx. This is your definition of the function. A more simplified form of the function. So this is your function now. So now you are asked to calculate what is the limiting value, limit extending to 0 plus. They are asking you to calculate what is limit extending to 0 plus fx. So limit extending to 0 plus and limit extending to n tends to infinity. So a double limit is there actually. F of 2 to the power of n times of x. This is what we are having. Now, how do you solve this thing? How do we solve this thing? This is the main concern. This is your function. Function is very simple. Okay, the limit is also very simple. You will see over here that this is limit n tends to infinity. Look at this thing. This is basically, here, first we are having limit n tends to infinity. As n tends to infinity, this is tending to 0. This quantity is tending to 0. What about this quantity? What about this quantity? This is a function. And this is dependent on both n as well as x tending to 0 plus. So one thing can you see over here, just use your brains to solve. Okay, people will try to solve this thing, but the very, if you solve it in a much more smarter way, you need to have a very strong visualization process. I mean, observation power actually. You can solve this in a much more smarter way. Just look at this thing over here. The range is given to you -1 to 1. So the range is what? Fixed. Range is what? Fixed. So this is what? This is any quantity. This function is any quantity. For any limiting value, this will be, the range will be from -1 to 1 only. For any larger value of x, this quantity will be still from -1 to 1. So it's basically 0 multiplied by any oscillating function. Okay, 0 multiplied by any value from -1 to 1. This can be anything from -1 to 1. So this will be 0 only. So option D will be correct, which is equal to 0. Look at this question. Question says a and b a sequence of real numbers defined recursively by a n plus 1. So some recursion is given. A n plus 1 is 3 times of a n divided by 2 plus a n for all n greater than or equal to 1. So the first part of the question says for a1 lying in between 0 and 1, we have to prove that an is increasing and limit n tends to infinity, an is 1. Okay, and the second part of the question says that if a1 is 1, then we have to prove that an is decreasing and limit n tends to infinity, an is 1. Okay, so the thing is, first part of the question says, first part, the both of the parts are having the first part, common first part, which is for some condition, you have to prove that the sequence is increasing or decreasing. So in this case, basically what you need to do is the first part of the question says, you just need to prove that the sequence is increasing. Increasing sequence means an plus 1, the definition is an plus 1 is more than an, and decreasing sequence means an plus 1 is less than an. Hopefully these things are known to you. An plus 1 is more than an and an plus 1 is less than an. These are the definitions of increasing and decreasing sequence respectively. Okay. So the first is basically to prove any sequence, some recursion is given and you are asked to prove that the sequence is increasing or decreasing. Obviously you have to go by induction. Obviously you have to go by induction over here. So I have got the solution here. You can see. So what I do is basically I consider this to be the base case. I consider this to be the base case where A1 lies in between 0 and 1. A1 lies in between 0 and 1. I consider this to be the base case. Okay. And assume that the second case, the induction hypothesis case, you consider that that AK lies in between 0 and 1 for some K belongs to N. Right. The second steps, what is the first step? Basically, first step you check for A1. First step you check for A1. Then the second step is basically your induction hypothesis test. You check for, in general, let's say you let this be true for, let's say, K values for some K belongs to N. And then you check for K plus 1. Right. So for the first time, I'm making it, let's say for the base case is basically 0 to 1. A1 lies in between 0 to 1. Assume that. Then the second step says, assume that AK lies in between 0 to 1 for some K belongs to N. Then third step, we will be checking for AK plus 1. So AK plus 1 will be 3AK divided by 2AK, right? And what are we proving over here? We are proving that, we will be proving that using induction, we will be proving that AK plus 1 also lies in between 0 and 1. AK plus 1 also lies in between 0 and 1. Okay, so AK plus 1 will be 3AK divided by 2 plus AK, means whatever they have given actually. I'm just simply replacing the value of N by K. And then you divide by AK over here on both the sides. You divide by AK over here. So this you divide by AK. So this becomes 3 upon 2 upon AK plus 1. Okay. Now, in the second step, you have taken that, you have considered that AK is less than 1. AK is less than. So using the second step, AK is less than 1. We are having 1 plus 2 upon AK. This quantity, 1 plus 2 upon AK is actually more than 3. Right? Very simple thing. AK is less than 1. AK is less than 1. So 1 by AK will be what? More than 1. 1 by AK will be more than 1. So 2 by AK will be what? More than 2. 2 by AK is 1 more than 2. And 1 plus 2 by AK will be more than 3. 2 plus 1, 3. Simple thing. Okay. That's what we are doing over here. And finally, we are getting this thing. So 3 upon. So once you divide this thing by 3, so 3 upon. You take the reciprocal. So 3 upon 2 upon AK plus 1 will be less than 1. And this is nothing but your AK plus 1 only from here. This is only your AK plus 1. So AK plus 1 is also less than 1. So you're just proving that AK plus 1 is less than 1. And also AK plus 1 is positive. How do you prove this thing that AK plus 1 is positive? AK plus 1 will be definitely positive because we have taken AK to be positive. Because if AK is positive, see over here, we have assumed that AK is positive here. So if AK is positive, which means this is positive. Okay, 3 times of positive divided by 2 plus positive quantity. So this is obviously positive quantity. So AK plus 1 is definitely a positive quantity. So AK plus 1 is also positive. So hence we are proving that AK plus 1 is also positive. So AK plus 1 lies in between 0 and 1. We have just proved that AK plus 1 lies in between 0 and 1. Okay. Next, what we will be doing? Next, we will be proving that the sequence is increasing sequence. The sequence is strictly increasing. So you can see over here. Next, what are we doing is, next we are just yet to prove that. We just need to prove that AN plus 1 is greater than AN. Right? So next what we do is AN plus 1. See, we are finding what is AN plus 1. We are dividing by AN over here. So we are getting 3 upon 2 plus an. Okay, and we just prove that an is also positive and also less than 1. An is less than 1, so 1 by an is what? More than 1. An is less than 1, so 1 by an is what? More than 1. Right? So basically we will be finding this thing 3 upon 2 plus an will be greater than 3 upon 2 plus 1. Right? So an plus 1 will be greater than an. We have just proved that an plus 1 will be greater than an. Clear? Clear or not? So which simply means that an is strictly increasing function. Sequence an is strictly increasing. Fine. Now the second part of the question. The second part of the question basically is taught under real analysis. This is something which is known as the monotone convergence theorem. If you don't know the monotone convergence theorem, but I'll state the monotone convergence theorem for you all. Okay. And then I'll proceed. Theorem is very simple. Theorem is very simple. Monotone convergence theorem is extremely simple thing. Okay. So what we have concluded actually, we have just concluded that an is strictly increasing. An is strictly increasing. Okay, strictly increasing. We have concluded this. Okay, and also what we have done, also we have concluded that an is also bounded. An is also bounded. The sequence an is also a bounded sequence. Sequence an is also a bounded sequence. Okay. Now, what is the monotone convergence theorem? Somewhere you may write this down. The monotone convergence theorem. Monotone convergence theorem. Somewhere you might write this down, that what is the monotone convergence theorem. Okay. Suppose if a sequence is strictly increasing, okay, and bounded above, let's say, and the sequence is also bounded above. If a sequence is strictly increasing and a sequence is bounded above, then the sequence is convergent. Then the sequence is convergent. What is the meaning of sequence convergent? What is the meaning of sequences convergent? Sequences convergent means this limit will exist. Limit n tends to infinity, an will be some finite quantity. This is the meaning. And similarly, the same thing will hold for, similar kind of thing will hold for decreasing sequence. If an is strictly decreasing, okay, and bounded below, if an is strictly decreasing and bounded below, then an is also convergent. That is, limit n tends to convergent simply means the limit will exist. The limit of the sequence will exist, and this will be equal to some real number. This will be some finite value actually. So see over here. So an is what? Strictly increasing. We have just proved that an is what? Strictly increasing, and an is also bounded. An is bounded above by 1. An is bounded above by 1. Right? An is bounded above. The range of the an is basically 1. An is bounded above by 1. Right? We have just proved this thing. So if we have proved this thing, so we can say that an is what? Convergent. That is limit n tends to infinity. Limit n tends to infinity, an will be L. This simply means an is convergent. Okay. Now they are asking you to prove that. Second part of the question says, see, increasing, and you have to prove that limit n tends to infinity, an is 1. You have to prove that limit n tends to infinity, an is 1. How do you prove this thing? So we'll take the help of this recurrence given. Now, because n tends to infinity, an is L. So n tends to infinity, an plus 1 will be also n, because n is a very large quantity. So if an is tending to L, so an plus 1 will also tend to L. So from this recurrence which they have given actually, if an plus 1, let's say suppose we have an plus 1 is equal to 3an upon 2 plus an. So once I take limit n tends to infinity on both the sides, limit n tends to infinity, what happens is the left hand side will also tend to L. Like I said, if an tends to L, for large quantities, an is tending to L, so an plus 1 will be also convergent. An plus 1 will also tend to L. This is one more point, you can write this down. So this will also tend to L. And finally, we are having 3 times of 3L divided by, you distribute the limit. So we are having 3L divided by 2 plus L. Then solve for L from here. So we'll get some quadratic here. That is 2 plus 2L plus L square is basically 3L. So L square minus L is equal to 0. L will be 0 or 1. L will be 0 or L will be 1. So you are getting 2 values over here. So 1 is one of the value. We are also getting 0. We just need to prove that this is the limit will be equal to 1 and not 0. How do you prove that this is 1 and not 0? Why 0 will be rejected? Bolo. How can we reject 0? How can we reject 0 over here and say that limit is equal to 1? Because L is basically your limit, right? L is basically your limit. How can we reject 0 and say that limit is basically 1? So you need to show some concrete proof for this thing. So see over here that the sequence was strictly increasing sequence. AN is strictly increasing. We know this thing. AN is strictly increasing, and strictly increasing means AN plus 1 is, we just proved that AN plus 1 is more than AN. By definition, AN plus 1 is strictly more than AN, right? Fine with this? So what is the meaning of this thing? Can I say from here that AN, AN is actually greater than, A1. AN is actually greater than A1 because the sequence is what? Increasing sequence. So in general, can I say this thing that AN is actually greater than A1 for all n belongs to Z? For all belongs to Z plus. Can I say this thing that AN, if the sequence is strictly increasing, can I say this thing that AN is actually greater than A1? Right? Can I say this thing? And also A1 is given to be more than 0. This quantity A1, also A1 is given to be more than 0. Best thing will be take limits on both the sides. If you take limits on both the sides, limit n tends to infinity, A1 will be A1 only because limit is dependent on n. This will be still A1 and this is less than limit n tends to infinity AN. Right? Now A1 is also positive. A1 is also positive. A1 is greater than 0. A1 is positive. A1 is greater than 0. So limit n tends to infinity AN, limit n tends to infinity AN will be also greater than 0. This quantity is also greater than 0. Got it? This quantity is also greater than 0, which means that L is also more than 0. L is greater than 0 because this is only your L, no? So L is also more than 0. So L cannot be 0. So L0 is not possible. L has to be 1. So therefore L has to be 1. And hence limit n tends to infinity. Limit n tends to infinity. We just proved that limit n tends to infinity, AN is equal to 1. Is the first part clear to you? What is the use of monotone convergence theorem then? Are monotone convergence theorem this na? Sequence is bounded above and sequence is convergent. Without knowing AN is convergent, how will you find the limit? Without knowing, you have to say ki AN is convergent. If AN is convergent, then only you are finding this thing. Then only you are finding L and all sort of things. L is given to be 3L divided by 2 plus n, and then you are finding the limit actually. You need to know that AN is convergent. Sequence is strictly increasing and bounded above. Then the sequence is convergent. Now you know that sequence is convergent. This simply means sequence is convergent. This step simply means sequence is convergent. Because of these two conditions, we know sequence is convergent. That is why you are finding the limit next. Otherwise, randomly, why will you find the limit? This is called the monotone convergence theorem, which is taught under real analysis when you learn sequences over there. Sequence 2. Next part of the question. Next part of the question says, for A1 more than 1, we have to prove that the sequence is decreasing. Okay, so in a similar way, we'll prove. So if for A1 more than 1, we'll take this to be the base case. So in a similar way, we'll take that, we'll consider the second step, we'll consider AK is more than 1 for some K belongs to N. Again, similarly, by principle of mathematical induction, we'll prove AK plus 1 is 3ak divided by 2 plus ak using this quantity. Again, we'll do the same thing. And then in a similar way, in the previous part, we have just proved that in the previous part, we just proved that this quantity ak plus 1, ak plus 1 was, where it is? ak, this quantity, we just proved that this quantity ak plus 1, this quantity is actually less than 1. So now in a similar way, you can try the proof of this thing, and similarly, you will prove that ak plus 1 will be more than 1. Obvious reasons. For the previous condition was from 0 to 1. So now we are having more than 1. So this quantity will be also more than 1. You can prove this thing. You can prove this thing. This quantity will be more than 1. Take it. So by PMI, you will prove that AK or AN will be strictly more than 1. By PMI, you will prove that AN will be strictly more than 1. Got it? Got it? Yes or no? AN will be strictly more than 1. Clear? So AN plus 1. So similarly, we find out what is AN plus 1. Now next, what we have to prove? We just prove that AN is more than 1. We just prove that AN is more than 1. Given that A1 is more than 1, we are proving AN is more than 1. So next, what we have to do? We have to prove that AN plus 1 is greater than, less than AN. Sorry. AN plus 1 is less than AN. The sequence is decreasing, no? The sequence is decreasing over here. So see what we are doing. So AN plus 1 is 3 times of AN divided by 2 plus AN. And again, we do the same thing. AN plus 1 divided by AN. Then we just prove, we are proving that this quantity will be less than 3 upon 2 plus 1. In the previous case, we had 3 upon, this quantity was more than 3 upon 2 plus 1. Now we are having less than 3 upon 2 plus 1. Similar way. You can do the proof in a similar way. Take it. So AN plus 1 will be strictly less than AN. We will simply prove that AN plus 1 will be strictly, once you cross multiply this thing, so AN plus 1 will be strictly, you can cross multiply, since because this is a positive inequality, a positive quantity, AN is a positive sequence. So AN plus 1 is strictly less than AN. You will obtain this thing, which simply means that the sequence is decreasing. So now the second part of the question, which says that, again, you have to prove that the limit n tends to infinity, AN will be still 1. Even if the sequence is decreasing sequence, the limit n tends to infinity, AN will be still 1. So in a similar way, we'll prove. In a similar way, both the methods are quite similar. So in a similar way, we will prove that using the monotone convergence theorem. What is it saying basically? If the sequence is decreasing, what we have proved basically, sequence is decreasing, right? Sequence is decreasing, as well as sequence is what? Sequence is bounded below. Sequence is also bounded below. Sequence is bounded below, right? Sequence is decreasing and sequence is also bounded below. Bounded below means the minimum value is given. And bounded below. Sequence is bounded below. We just prove this. This means bounded below. Okay. This simply means bounded below. We just prove that in the second part of the question, we just prove that sequence is bounded below by 1. This simply means AN is convergent. Using the monotone convergence theorem, this simply means AN is convergent. And if AN is convergent, which simply means that limit n tends to infinity, both have the same meaning. Limit n tends to infinity, AN will be some finite quantity L. So again, we'll do the same thing. Yes, we'll take the reference, we'll take the help of this recurrence which they have given. That is AN plus 1 is 3 times of AN divided by 2 plus AN. So sir, we'll get the same value then. Yes, we'll get the same value. We'll get the same value if you take limits on both the sides. Limit n tends to infinity, AN plus 1. So 3 times of, again, limit n tends to infinity, 3 times of AN divided by 2 plus AN. Again, you will take L over here, because if this tends to L, which means AN plus 1 will also tend to L. AN plus 1 will also tend to L. So L will be equal to 3L divided by 2 plus L. Okay, 3L divided by 2 plus L. So similarly, using the same logic, you will be getting L is 0 or 1. Similarly, you will obtain, the value will be the same, L is 0 or 1. Now you have to again prove that L is only 1. You cannot take 0. L is 1. So how will you prove this thing? L has to be 1 and L cannot be 0. You just need to prove this thing, because they have asked to prove that the limit is tending to, as limit n tends to infinity, the limit is basically 1. So how will you prove this thing? Simple thing. That suppose you see over here, visualize this thing, visualize. You have 0 somewhere here, here we are having 1. So your sequence is what? Sequence is decreasing over here. Your sequence is decreasing. This sequence AN is continuously decreasing over here. and the sequence somewhere over here, not here, sequence an is decreasing and is bounded below by 1. Sequence is decreasing over here. Sequence is decreasing and the sequence is bounded below by 1. Got it? Sequence is bounded below by 1. Now the thing is, suppose if I take any quantity over here, let's say for any real number somewhere over here, you just need to prove that the limiting value is basically 1 and not 0. 1 and not 0. Suppose we visualize this thing. If I take any quantity over here, let's say t belongs to 0 to 1. For any real value t belongs to 0 to 1. Okay, for all t belongs to real numbers. You take any real t over here. So can you see over here that an is definitely greater than 1. An is definitely greater than 1, right? An quantity, an sequence is definitely greater than 1. We know this thing. And which we have taken t is also more than 1. Or sorry, 1 is more than t. 1 is more than t. Right? 1 is more than t. Okay. And t is also positive. So t is definitely positive. So an is what? Positive. An is what? Positive. Or rather, if you take limit over here, the limiting value will be also positive. Limit n tends to infinity, an is also positive. This will be also positive. Limit n tends to infinity, an will be also positive. So this quantity cannot be, the limit n tends to infinity, an cannot be 0. This has to be 1. So therefore, limit n tends to infinity, an has to be equal to 1. Did you all get this thing? A very nice question on sequence. Okay, next we move on to 2014 PYQs. This is the first question which we are having. Limit extending to 0. Sin alpha x divided by x exists only when for which of these following conditions? So limit extending to 0, sin of alpha x divided by x. This exists when for which of these following conditions we have to check over here. So we can verify. Let's say if alpha is 1. If alpha is 1, so definitely this is true, which is the standard limit. But is this the only value? Limit extending to 0, if alpha is 1, this will become sin x upon x, which definitely exists. But is this the only value? This is what you need to verify. Because option A and option C also has equalities. So A or C could have been much more general answer. You have to verify each and every options. You know this thing that this is a standard limit. So B can be one of the options. Okay. Now alpha is a positive integer. Is this true for positive integer only? Is this not true for decimals or something? So you can verify this thing. Let's say I'm taking limit extending to, you take a decimal value. Let's say, for instance, I'm taking limit sin 2.5, let's say, raised to the power of 2.5 divided by x. Will this exist? Will this limit exist? How do you know this thing? So one thing you can do is basically you can write this as limit extending to 0, sin x, sin x divided by x, then multiplied by sin of 1.5. We can do this thing. Sin of 1.5, or rather sin x whole to the power of 1.5. We can do this thing. Why do we do this thing? Because sin x upon x will tend to 1. And as x tends to 0, 0 raised to the power of 1.5 will definitely exist, which is 0 only. So yes, if alpha is a positive integer, even if it is not a positive integer, still the limit will exist. So D is definitely wrong. D is definitely wrong. Right? D is definitely wrong. Okay. So next, we have checked B, we have checked D. Let's check, let's come down to C. Alpha is less than 1. Alpha is less than 1. Will this work out? For alpha less than 1, take alpha is 0.5, let's say. Verify. Take alpha to be 0.5. So we have limit extending to 0, sin of 0.5, 0.5x divided by x. Again, target will be to bring this in terms of sin x upon x format, right? Target will be to bring this in terms of sin x upon x format. Let us multiply and divide by sin of 0.5x. Okay, sine of 0.5x divided by sine of 0.5x. Let's see what we can get from here. The numerator will become what? The numerator will become sin x. The numerator will become sin x. The numerator will become sin x. This quantity will become sin x upon x. This quantity will become sin x upon x. So limit extending to 0 sin x upon x into 1 upon sine of 0.5x. Sin x whole to the power of 0.5. Okay, sin x whole to the power of 0.5. This quantity will tend to 1. This quantity will tend to 1, right? But what about this quantity? As x tends to 0, this will become sine 0. No, 1 by 0. 1 by 0 raised to the power of 0.5. So this will not exist then. As x tends to 0, this quantity will become 1. And this will become 1 by sine of 0. So 1 by 0 and 1 by 0 is undefined. I mean, this will tend to infinity. So in this case also, this will not exist. So option C is also wrong. Option C is also wrong. Okay, they are asking you that this will exist only when. Now the thing is, one thing you can see from here, we have checked that alpha is a positive integer. Even if it is not a positive integer, even for decimal also, this is holding. Even for decimals, 2.5 or something, this still holds. This will still give you some fixed value. The limit will hold, right? So alpha is equal to 1 is also not possible. Alpha is equal to 1 is also not possible. This option will be also discarded. The reason being, even if it is a decimal, even for decimal values, it is still holding. And they are saying the limit exists only when, only for which condition? If alpha is only 1, even if it is not 1, then also for some of the values, this is holding. For 2.5, 3.5, 4.5, this will still hold, right? So most likely, option A will be correct. And you can check over here, alpha is greater than or equal to 1. If let's say alpha is 2, let's say. So limit extending to 0, sine square x divided by x. This will still exist because you can see over here, limit extending to 0, you can write this as sine x divided by x and then into sine x. So this quantity becomes 1 and sine of 0 is 0 only. So this will become 0. So this limit will exist. So clearly option A must be correct. Okay, next we have this question which says that f such that 0 to infinity be a function differentiable at 3. Okay, the function is differentiable at 3 and which is satisfying f of 3 is equal to 3 times of f dash of 3. This is satisfying this relation actually. Okay, so, and this is positive. Okay, this quantity is also positive quantity. Then the limit extending to infinity, this quantity is how much? So if you figure out this thing, that limit as x tends to infinity, this is tending to 0 and we will be having f3 divided by f3, which is 1. And so this is of the form 1 raised to the power of infinity. This is of the form 1 raised to the power of infinity, right? So we can directly use the formula. What is the formula? E raised to the power of limit extending to infinity fx minus 1. So this minus 1, gx will come down, fx minus 1, f of 3 plus 3 by x divided by f3 minus of 1, right? So now we simplify this thing. So we have limit e raised to the power of limit extending to infinity. So x times of, we take this LCM. So we are having f of 3 plus 3 by x minus of f of 3 divided by x divided by f of 3. Okay, divided by f of 3. This is what we are having, right? So now can we say from here, we have some relation they have given. Next, can we simplify this thing as e raised to the power of limit extending to infinity? Can I write this thing? Yes, just forcefully take 1 3 over here. You will get to see the simplifications. If you forcefully take 1 3 over here, can you see from here? Just forcefully take 1 3. So can you see over here that we are getting f of x plus 3, f of 3 plus 3 by x, right? Minus of f of 3, right? Divided by f of 3, and bring this x down. So we are having 3 by x. We are having 3 by x. And one more 3 is remaining outside. One more 3 is remaining outside. One more 3 is remaining outside. Okay. Okay. So the thing is, why we have done this thing? Why we have done this thing? Can you see over here that this is nothing but the definition of differentiability? This is nothing but the definition of differentiability as x tends to infinity. Change this to h tends to 0. As x tends to infinity, this is tending to 0, right? 3 by x tends to 0. So if I take 3 by x as h, so basically we will be having f of 3 plus h minus of f of 3 divided by h, right? Where h is 3 by x. Yes or no? So as x tends to infinity, h will tend to 0. So this is nothing but f dash of 3. Yes or no? This is nothing but f dash of 3. So we are having e raised to the power of 3 times of f dash of 3 divided by 3. F dash of 3 divided by f of 3. Right? F dash of 3 divided by 3. And this ratio is given to be 3 times of f dash of 3 divided by f of 3 is given to be 1. This is given to be 1. This ratio is given to be 1. So your answer is basically E. Option B is correct. Okay, we move on to ISI 2013 PYQs. Here the first question. The first question says limit extending to infinity 3 to the power of x plus 7 to the power of x whole to the power of 1 by x. And these are quite routine questions, normal questions which are taught at the very basic level. What is the logic? Basically, whichever quantity is bigger, you simply take this out. Whenever you have this format, no, a raised to the power of x plus b raised to the power of x whole raised to the power of 1 by x. Take the bigger quantity out as x tends to infinity. Take the bigger quantity out, right? Why we take the bigger quantity out? Because we need to bring into this form, like something like limit x tending to infinity, x to the power of n, right? This will tend to 0 if not x, basically, as limit x tending to limit n tends to infinity, x to the power of n will tend to 0 if x lies in between, if mod of x is less than 1. And a mod of x is less than 1. If this quantity is true, we take out the highest power common over here, highest value common. So limit extending to infinity, you take out 7 common from here. So 7 raised to the power of x whole to the power of 1 by x comes out. So 7 comes out. This becomes 3 by 7 raised to the power of x plus 1 raised to the power of 1 by x. So now as x tends to infinity, this will tend to 0. This will tend to 0. So we have 0 plus 1 raised to the power of 1 by infinity, which is also tending to 0. So it's 1 raised to the power of 0, which is 1 only. And your final answer will be 7. Option A is correct. Finally, we have the last question. It's a UGB question. F such that R2R be a function such that mod of fx plus y minus fx minus y is less than or equal to y squared. So some functional inequation is given. For all x belongs to real numbers, xy belongs to real numbers. So you have to show that fx is x by 2 plus c. Okay. So these are quite common formats. I have said this in my limit lectures as well, that these are quite common formats. F of x plus y minus of fx minus y. These formats are quite common, right? So basically you have, first you break this mod over here. So once you break this mod over here, so we get f of x plus y minus of f of x minus y minus y. This quantity is lying in between minus y square and y square. Minus y square and y square. You break this mod over here, right? So we are having x plus y and x minus y. F of x plus y and f of x minus y. For simplicity, what I'll do is I'll take this x plus y as t plus h and x minus y as t minus h, or t rather, not t minus h, t. X plus y is t plus h and x minus y is t. The reason being, we can find the value of, in terms of y, we can find the value of any one variable in terms of one variable. Okay, here t belongs to all real numbers and h is the same h, which you all know. H is a very small quantity, which is positive quantity. Why we are doing this thing? We'll get some format over here, some known formats over here. Okay, we can do these kind of replacement in functional equations or inequations, because this is true for all x, y belongs to R. So y will be how much? Y will be h by 2 from here. You simplify from here, simply add, subtract these two, you will be getting y to be h by 2, right? So we have everything in terms of one variable, where h is a positive quantity and t belongs to r. So we have h, this will become h by 4, h square by 4, minus of h square by 4, less than or equal to f of t plus h, minus of f of t minus, sorry, t, f of t. X minus y is basically t only. And minus of y, so minus of h by 2 is less than or equal to y square. Y square means h square by 4. So once you add h by 2 on both the sides, so we are having h square by 4 plus h by 2 less than or equal to f of t plus h, minus of ft less than or equal to h square by 4 plus h by 2. So can you see over here that we are getting some formats of differentiation? F of a plus h minus of fh, fa divided by h. So one h is missing. So one of this h is missing. So we can just forcefully divide by h over here. We can just simply divide by h over here and all three sides, right? We can simply divide by h such that this one of the h will cancel out and this will become minus of h by 4. So this becomes minus of h by 4 plus half less than or equal to f of t plus h minus of ft divided by h less than or equal to, similarly h and h will cancel over here. So we are left out with h plus h by 4 plus half on the right hand side. So can we now just take the h tends to 0 over here? Because h is the smallest quantity, so h limit h tends to 0. We are taking h tends to 0 on all three sides. Limit h tends to 0. So as h tends to 0, this quantity will become 0 and we are left out with half over here, half less than or equal to. Similarly, this quantity is nothing but f dash of t, sorry. This is nothing but f dash of t less than or equal to. Similarly, this quantity will become 0 and you're left out with half. So by sandwich theorem, we can say f dash of t will be half. So by sandwich theorem, we can say f dash of t is half. So once you have found out what is f dash of t, we can find what is ft. What is ft? Ft will be, integrate this on both the sides. So we have ft will be half t plus c. Integrating on both the sides, we get ft to be half t plus c. And that's what they have asked to prove. Show that fx is x by 2 plus c. So fx will be, you just simply change the variable, fx will be x by 2 plus c, where c is just a constant. Okay, that's what they have asked to prove. Okay, now this question could have been further extended. They could have just simply, give some more conditions. If this question is given nowadays, they can give more conditions. More conditions in the sense means they'll make you find what is c. They'll make you find what is c. They can give you more conditions. They'll make you find what is c. They'll give some more conditions like f of 0 is 1, f of 2 is something, and they'll make you find out c, and they might, find some particular value of c. Using some particular value of c, find the particular solution. What is the particular function you're getting over there? This can be one question.